Good evening, everyone. Nice to be back again after a couple of weeks, after a long, hard algebra session of around 3 hours. Um, I hope I'm audible. I hope everyone, can see me fine as well. If you can quickly confirm in the chat window, it would be great. All right. So let me share my screen as well. Good evening again. Hello, Krishnan. So we're gonna in for a power pack session again today, right? Just giving you a heads up, guys. It's gonna be a long session. My sessions normally shoot over, so maybe keep something to eat or an energy drink ready at the side, and we'll get started right away. I'm sharing my screen, and we are on. All right, just confirming. Can all of you all confirm that you're able to see my screen? I'll be shifting between a PPT as well as a sketchbook. All right. Okay. So before we start, what are your expectations from this session? It's been, I think 5 years back, maybe 6 years, I did do an inequality session on GMAT Club, and that session, got a lot of love from you guys. So um, I am again doing an inequality session, a more exhaustive one, I would say, where I cater to every inequality concept that is required. I'm not mixing absolute values along with it. We'll have a separate session on absolute values where I focus on only the absolute value. So this session will deal with everything that you require on inequalities from a GMAT Focus edition perspective. All right. So there's not going to be data sufficiency questions on pure math topics. So you're not going to find data sufficiency questions on inequalities too many, right? But inequality questions that are going to be tested on the quant section a lot more. So there's going to be a different varieties of questions, problem solving ones, must be, could be kinds of questions that we will be tackling. Okay, so without any further ado, I would start. Let me shift to my sketchbook and let's start a discussion. All right, so what exactly are inequalities? I'm gonna split this entire session into three parts. The first part, we deal with the fundamental rules of inequalities, see how they integrate with algebra, and then take some illustrative examples to reinforce those concepts. Then we'll go into part two, where we discuss how to tackle must be, could be kind of questions. And then we'll go into part three, more advanced concept of inequalities with illustrative examples again. And finally, we'll end with a mixed bag of a couple of questions. In the event that you have to log out because it's too late, remember the session is going to be uploaded on YouTube. I will also give the admin a PDF copy of the slides with handwritten explanations for the questions I may not have time to discuss, but that link will be provided for you all to download. All right, so let's start quickly. What are the inequalities that you have? So less than, greater than, less than or equal to, greater than or equal to, and not equal to. Now, this entire topic of inequalities hinges on your understanding of four fundamental rules. Okay, these are, I would say, the most important rules of inequalities that you'll have to cater to everywhere when you work with inequality questions. Very simple, most of you all might already know it. I'm going to quickly reiterate it, and then we look at a set of questions on how to break things down well. So if I take an example, right, let's say 20 is greater than 10, a true inequality. If I add a constant 5 to both sides of the inequality, I'm going to get 25, I'm going to get 15. So the inequality sign did not change, it remained the same. And similarly, if I subtract a constant 5 on both sides, I'm going to get 15, I'm going to get 5. 15 is still greater than 5. So I don't need to worry about the inequality sign. So the first of the four fundamental rules states that you can add or subtract any quantity. And when I write any quantity, I mean any quantity. It can be a number, it can also be a variable. You can add or subtract any quantity on both sides of the inequality, and the inequality sign remains unchanged. Many test takers ask me a question here. Can I add variables on both sides? You can definitely add variables on both sides. So if you have something like 2x is less than x plus 4, you treat it exactly the same way as what you would do with an equality, right? So you would subtract x on both sides, or like what we do here, we pull the x to the left hand side. It's absolutely okay to do manipulations with addition and subtraction when you're working with inequalities. It does not change as compared to equalities, right? So x would be less than 4 here. So you can add or subtract any quantity you want on both sides, and the inequality sign remains unchanged. Second, again, let's use a simple example. 20 is greater than 10. If I subtract 5, or let's multiply this time, right? If I multiply both sides of the inequality by a positive quantity, let's say 5. So 100 is greater than 50. So the inequality sign again remains the same. And if I divide both sides by a 5, I'm going to get 4, I'm going to get 2. 4 is still greater than 2. So the second of the fundamental rules says you can multiply or divide both sides of an inequality with a positive quantity, and the inequality sign remains the same. You can multiply or divide both sides with a positive quantity. If you know that the sign of the quantity is positive, you can multiply or divide both sides. And third, let's see what happens when we multiply and divide the negative quantity. So if I multiply both sides by minus 2, 20 into minus 2 will give me minus 40. 10 into minus 2 will give me minus 20. Minus 40 is going to be less than minus 20. Similarly, if I divide both sides by a negative 2, so I'm going to divide both sides with a negative 2. 20 divided by negative 2 will be a minus 10. 10 divided by negative 2 will be a minus 5. Minus 10 is less than minus 5. So see, the inequality sign flips. So the third of the four fundamental rules states you can multiply or divide both sides with a negative quantity. But if you do that, the inequality sign flips. Now, most of y'all would know these three fundamental rules. These govern the entire set of things that we're going to discuss beyond the four fundamental rules as well. So ensure that you know these fundamental properties, please. Now let's look at the fourth one, right? A very important one is this is where most test takers make a mistake as well. The fourth of the fundamental rules. The fourth fundamental rule depends upon your understanding of the previous three. So if I take an example, x by y is greater than 1. If I give you this equation, now normally if I give you an equality, x by y is equal to 1, you would, take the y to the right hand side and say x is equal to y, right? Can you do the same with an inequality here? Can you multiply both sides with a variable? Can I write this as x is greater than y? Can I cross multiply and say x is greater than y? Anybody? Is it correct for me to? Yes. So I cannot multiply or divide both sides of an inequality with a variable until I know the sign of that variable. I cannot multiply both sides by y because I'm unsure about the sign of y. They have not told me anything about the sign of y. So I'll not know if I multiply both sides by y, whether I'll have to keep the inequality sign the same or to flip it, right? So the fourth fundamental rule states you can never multiply or divide both sides of an inequality with a variable until you know the sign of the variable. If you know the sign, you can definitely go ahead and do it, right? I'll add one more, pointer here. And this is something that you also need to hold on to, especially while working with questions on an inequality topic. Remember, you cannot multiply or divide both sides with a variable until you know the sign of that variable. But what if the sign of the variable is given to you? What if I give you the same equation, but I give you y is greater than 0? Now, y is greater than 0. Since I know y is positive, I can multiply both sides by y. And by multiplying both sides by y, I know I can keep the inequality sign the same. So x would be greater than y. And even if they told me that y is less than 0, I can still multiply both sides by y. But since I'm multiplying both sides with a negative quantity, I'll need to flip the inequality sign. So x would be less than y. So the point I want you to hold on to here is this. Whenever you see an inequality-based question, if you have information about the sign of a variable, it is crucial information that you've been given. Because if you know the sign of a specific variable, you can manipulate using multiplication and division with that variable. Normally, if you don't know the signs of any variables, you're only constrained to one kind of mathematical operation. You're only constrained to addition and subtraction, because that doesn't change sign. That doesn't affect the inequality sign. But if you know the sign of a variable, it's huge pieces of information that you've been given. Why? Because it opens up that possibility for you to manipulate using multiplication and division. So remember, whenever you see an inequality question, if the sign of a variable is given to you, make a note of it. It's crucial information. It opens up the possibility to manipulate using multiplication and division. Whenever you see a question where the constraints are given to you and some of the constraints are the signs of variables, always make a note of them. Remember, you can always multiply and divide with a variable. It makes your algebra working a lot more simpler. Another add-on. Can you multiply or divide both sides of an inequality by an even powered term? Can all of you all type in the chat window? Is it possible for me to multiply or divide both sides using an even powered term, something like x square or x to the power of 4? Would that be possible? Yes, it is positive. Yes, okay. All right. There's a catch here. You can multiply and divide both sides with an even power term, but it has to be conditioned to the term not being equal to 0. What you need to understand here is this, right? When you have a square term is not positive, right? A square term is non-negative. The meaning of non-negative is it should be 0 or positive, right? So you can multiply or divide both sides by an even power term condition to that term not being equal to 0. Make sense? So the fourth fundamental rule states you can never multiply or divide both sides of the variable until you know the sign of the variable. Remember, if the sign is given, it's very, very important pieces of information that you have because it opens up the possibility for you to manipulate using multiplication and division. And you can multiply and divide both sides by an even powered term, but it could be conditioned to that term not being equal to 0. You can't multiply both sides by 0. If you multiply both sides by 0, then you're getting 0 on one side and 0 on the other. 0 can't be greater than 0 or less than 0, right? So it has to be conditioned to the term not being equal to 0. So I've just kicked off with the first 4 fundamental rules, I would say the most important fundamental rules of this topic. I'm also going to delve a little bit into some guidelines towards working with inequalities as well, right? I'm going to not dump all the properties and then work with it. I'm going to give you some guidelines as well in addition to the 4 fundamental rules. And then we'll go into, a couple of questions and work with it, right? Any doubts on what we've done so far? All right. Okay. So couple of guidelines that I want to also put in here is whenever you're working with the topic of inequalities, you have to have a very good understanding of the number line. How to plot ranges on the number line, how to understand negative numbers on the number line, right? Very, very important. So the first thing that I want to speak about is how do you plot inequalities on the number line? So let's me take x is greater than 3. Now, this kind of inequality is what we refer to as an infinite range. Why? Because it represents an infinite portion on the number line. And if I quickly want to plot this on the number line, I'm going to put in 0, I'm going to put in a 3. Since x is greater than 3, I'm going to put a circle on the boundary. I'm not going to shade that circle because they're not asking me to include 3, but I'm going to shade everything to the right of 3. Remember, on the number line, greater than means to the right, lesser than means to the left. And as we go from left to right on the number line, the values become larger and larger and larger. Similarly, if I have an x is less than or equal to 3, another infinite range, I would again plot the boundary that is 3, put a circle on that boundary. I would shade the boundary as well and shade everything to the left of 3, right? So x would be less than or equal to 3. You can also have something called finite ranges. Something like -4 is less than or equal to x is less than or equal to 5. This is what we refer to as a finite range. It's called a finite range because it represents a finite portion on the number line, right? And normally a finite range will have multiple inequalities combined. So basically this is how you read it. X should be greater than -4 but less than 5, or x should be in between minus 4 and 5 inclusive of the 2. So again, if I want to plot this out, I'll plot out the minus 4, I'll plot out the plus 5. I'm going to put shaded circles at the boundaries and shade everything in between, right? So that's the first thing I want you to hold on to. How do you plot inequality ranges on the number line? Second, while working with inequalities, you have to be well versed with your understanding of negative numbers. So if I give you two negative numbers, minus 3 and minus 2, and I ask you which of these two numbers is bigger, now clearly the answer here would be minus 2. And there's two reasons you would give me minus 2 as the answer. You would say, one, that minus 2 is closer to 0 on the number line, right? Or you say that minus 3 is to the left of minus 2 on the number line, right? So remember, on the number line, as you're going from left to right on the number line, the values start increasing, right? So values that on the negative side that are away from 0 are smaller, that are closer to 0 is larger. And on the right hand side of 0 on the number line, the values closer to 0 are smaller, and the values away from 0 are larger. But what if I give you, very, very small fractions? Remember, we don't have the calculator facility on the quant section. So if I give you something like minus 17 by 19 and minus 21 by 23, and I ask you to compare these two fractions and tell me which one is bigger and which one is smaller. Now, it would be very difficult for me to visualize, because it's a range between 0 and minus 1. It would be very difficult for me to visualize which of these two decimals is closer to 0. So anytime you see, two values and you're unsure, especially decimal values, and you're unsure which one of the two is greater, the best way to work is to just cross multiply. Take the numerator of the first, multiply it with the denominator of the second. Minus 17 into 23, what's my 17 threes are 51, 17 twos are 34, plus 5, that will be minus 391. So you take the numerator of the first, multiply it with the denominator of the second, place the product under the fraction that you're taking the numerator from. And do the same for the next as well. Take the numerator of the second, multiply it with the denominator of the first, and place that product below the fraction that you're taking the numerator from. So 19 times minus 21, 19 times 20 is minus 380, plus 19 is minus 399. Now, out of minus 391 and minus 399, clearly minus 391 is bigger, because minus 399 is to the left of minus 391, or minus 391 is closer to 0 as compared to minus 399. So that makes minus 17 by 19 the greater fraction. And you can use this process for any sort of fractions, okay? Anytime you're unsure out of two fractions which one is bigger, quickly cross multiply. Another process to figure out which is the greater of two fractions is, obviously, if you look at the number systems process of working, taking the LCM, right? And working with the numerator, but taking the LCM here is again going to be, a tough proposition of 19 and 23. All right. So this is the second bit. This is the second guideline that I want to put in. The third, very important, and most test takers get confused in the next bit, is how do you combine ranges on the number line? Okay, how do you combine ranges on the number line? Now, whenever you're given multiple ranges, you have to decide whether you're going to combine those ranges on the number line and get an overall range, or whether the given ranges are going to hold on their own. So for example, if I need to combine ranges, everything will depend upon what kind of inequality ranges I've been given, and whether there is an AND condition that runs between them, or an OR condition that runs between them. Whenever you have an OR condition that runs between ranges, they will never overlap. both the ranges will hold good on their own, and they will represent two non-intersecting regions on the number line. For example, x is greater than 3 or x is less than minus 3. Remember, when you break down a quadratic equation, right, and you solve for the solutions of a quadratic equation, what you end up getting are two solutions, sometimes one solution, if the solutions are the same. Say we get two solutions. You would say x is equal to 3 or x is equal to 2, right? Because both of them on their own are definite possibilities. Similarly, when you work with inequalities as well, if you have an OR condition that runs, both the ranges will hold on their own and both of them would be a part of your solution. There will never be an overlap when you have an OR condition. So I have minus 3, I have plus 3, x is greater than 3, that would be my first range, x is less than minus 3, that would be my second range. Yes? So an OR condition is relatively simple, right? An OR condition means you're never going to have an overlap. Both the ranges that are given to you or the multiple ranges that are given to you will be exclusive portions on the number line, and all of those regions will hold as solutions. But when you have an AND condition that runs between ranges, that is when you have to be slightly careful. When you have an AND condition, I need both, or I need all the conditions to be satisfied simultaneously. For example, if I give you x is greater than 3 and x is greater than 5, if I use the word and between the two, I need both conditions to be satisfied simultaneously. Meaning of that, I need a value for x that satisfies the first condition and also satisfies the second condition at once. Right? So x is greater than 3 and x is greater than 5. If I take 3, if I take 5, I will need to consider, whenever I have an AND condition, I will have to always consider the overlap. So x is greater than 3 and x is greater than 5. The overlap happens beyond 5. So the overall range of x would be x is greater than 5. So remember, an OR condition means both the ranges are going to hold on their own, would be part of your solutions. An AND condition means you have to consider the overlap. Got it? So if I give you a simple range like this, let's say y is between minus 10 and plus 10 and y is less than 2. Can you all quickly visualize both the ranges on the number line, plot it out, and then give me what would be the overall range for y that I would consider? What do you think would be the overall range of y? Quickly type in the chat window. Yes. So the first, I'm dealing with minus 10 to plus 10. I'm going to plot that. And then I have y to be less than 2. So you see, the overlap happens between minus 10 and 2. So that would be my overall range for y. Let's make it more complex. Let's say x is between half and 2 by 3 and x is less than 3. So can all of you give a shot and give me what would be the overall range for x here? All right, I think the GMAT logo is coming on the right hand side of the screen. I will not go that, I will not write that right hand portion next time. All right. Okay, if I give you x to be between half and 2 by 3 and x to be less than 3, what would be the overall range that I get for x? What do you think? It would be half and 2 by 3 itself. So let's plot it out, right? So I have 0, I have half, I have 2 by 3, and I have 3. So the first range tells me x is between half and 2 by 3. The second range tells me x is less than 3. So I need the portion that overlaps between the two. So that's between half and 2 by 3. Let's make it even more complex. So I'm going to give you x is greater than 3 or x is less than minus 3 and x is between minus 5 and plus 6. So now I've given you 3 ranges. X is greater than 3 or x is less than minus 3 and x is in between minus 5 and 6. So what would be the overall range of x? Don't try to do it in your head. Plot it out, visualize the regions, see where it overlaps. What would be the overall range for x? Amanda says between 3 and 6. Okay. Only one, Amanda? Between minus 3 and 3. Okay, minus 5 to minus 3, union 3 and 6. Yes. Okay. So very simple. For those of you all who are still not getting this, plot them on the number line first. So I have minus 3, I have plus 3, minus 5, plus 6. So the first tells me x is greater than 3. The second says x is less than minus 3. Remember, it's an OR condition, so I don't need to worry about these two. They will hold on their own. And now there's an AND condition between this inequality. So when there's an AND condition, there'll be an overlap. I need to consider the overlap. So minus 5 plus 6, non-inclusive of the 2. I draw that. And where do all the regions overlap? Between minus 5 and minus 3 and between 3 and 6. So x will be in between minus 5 and minus 3, or x would be between 3 and 6. That would be the overall range for x. It's very important that you know how to combine ranges on the number line, because that's going to be the crux of something we do later, right? Where you're going to deal with multiple ranges and you'll have to plot them out. So remember, when you have an AND condition, you need to consider the overlaps. Any doubts on this? For those who gave me different ranges, did you understand? Why not AND? Because there's no overlap between these two, right? These two ranges that I've shaded, that overlap between everything, are two ranges that are exclusive to each other, right? There's no overlap. No, if I say minus 5 and minus 3 and 3 and 6, basically it's going to change the entire meaning, right? If I use the word AND here, then you are telling me I need a value of x that satisfies this and also satisfies this, and I'll not have any value of x that is between minus 5 and minus 3 and also between 3 and 6, right? An AND condition only runs when you have an overlap between the ranges. All right. So you'll be very careful with this, guys, right? You need to understand where an OR condition runs and where an AND condition runs. Remember, OR conditions hold good on their own. There'll never be an overlap between them. AND conditions require an overlap. You need to consider the overlapping region, because both conditions need to be satisfied when you have an AND involved. All right. Okay. The third guideline. So the first was number line, how to plot things out on the number line, how to visualize negative numbers on the number line. The second is how to combine ranges on the number line using and or. And the third, very, very important, whenever you work with an inequality based question, you have to approach any inequality question using a process of algebra and analysis. Many test takers approach an inequality question directly by putting in values. Remember, putting in values is not going to be a foolproof process of working. Putting in values will help you disprove certain things, but to prove something is going to be very difficult with values. You'll always be left with a inkling of doubt in your head whether you've tested for multiple values or not. And on top of that, if I'm using values, I'll have to use different sets of values. I can't just run an analysis with only one value. So whenever we work with an inequality question or even an absolute value question, the first instinct that you should have should always be to try to use algebra and then analyze. This should always be a first mode of approach. Right? It should always be a first mode of approach. And what do I mean by algebra and analysis? What do you do? Right? Why am I writing algebra along with analysis? I'm writing algebra first and analysis second. Because it's very important for you, right, when you're working with inequalities, to first set the question up using algebra. What normally people do, right, and why they don't prefer the analytical way of working is because they dive right into trying to analyze. And what happens when they dive right into analyze, there's multiple things that they have to work with, there's multiple cases they'll have to consider, and then what happens, it becomes too overwhelming, and then you would debunk that process, and then you would work with putting in values because you're more comfortable doing that. But again, putting in values is a different ball game altogether. So why am I integrating algebra and analysis here? Because the first thing you need to do whenever you work with an inequality question is you need to set up the question such that it is conducive to analysis. You should always approach the question from an algebra and analysis standpoint, but you need to learn to set up the question such that it is conducive to analysis. Now, how do I do this? How do I do this? Now, this is where the basic 101s of algebra, the guidelines of algebra come into play, right? And we discussed the guidelines of algebra in the first algebra session that was held approximately a couple of weeks back, right? So for those of you all who've not gone through that and want to see what the guidelines of algebra is, please revisit that video, have a look at it before you start working with your inequality based questions. Okay, I set up certain guidelines and certain rules very well in the algebra session. That's going to come in handy here. So you have to keep in mind those basic rules of working with fundamental algebra. In addition to that, when you're working with the inequalities topic, right, you have to think about integrating rules of inequalities to break questions down. So what do you do to set up the question such that it is conducive to analysis? One, you have to ensure that you follow what I call 3 golden rules. These 3 golden rules will help you set up an inequality question and set it up perfectly for you to do an analysis based on sign and based on magnitude. The first of the 3 golden rules. Always try to keep the right-hand side of the inequality as 0. Think about it, right? If I keep the right-hand side of the inequality as 0, then it's very easy for me to analyze on what the sign of the left-hand side is. If x plus y is greater than 0, I know x plus y has to be positive. And remember, that's our entire focus. Our focus is to try to analyze things based on sign and based on magnitude. So keeping the right-hand side as 0 helps with figuring out the sign of the left-hand side. And what do I do to the left-hand side? I will always factorize the left-hand side to a product or a division of terms. Why do we prefer to set up algebraic expressions in terms of products and divisions because they're easier to break down. They are easier to analyze, right? I've mentioned this before in the algebra session as well. When I give you something like xy is less than 0, I would prefer this equation any day towards x plus y is less than 0, because in the first case, all I have to do is analyze based on sign, and I can clearly, looking at it, I can say that the signs of x and y have to be opposite. But in x plus y is less than 0, in addition to analyzing with the sign, I have to bring in magnitude analysis as well. So wherever possible, right? If you have the option of taking some terms out common, making it into a product or a division of values, I would always do it because it's going to help me in analysis based on sign. And third of the golden rules, always factor out even powered terms. Always factor out even powered terms. What do I mean by that? Even powered terms are good for you in an equation. Why? Because you can analyze and you can ignore them. So if I give you an equation x square y is less than 0, just by looking at the equation, I know I can analyze that y has to be negative here. I can ignore the x square because it's positive, right? Obviously, it's not going to be equal to 0 here, because if x takes a value of 0, it will violate the inequality. Similarly, if I give you something like x cube y is less than 0, the best way to analyze such an equation is not to do it directly. Whenever you have the option of pulling out and factoring out an even powered term, take it out, because you can always eliminate them. You can ignore the even powered terms. So I would write this as x square times xy is less than 0. And I would just say x square is always going to be positive. So this equation boils down to me analyzing the product of xy being less than 0, and x and y have to be of opposite signs. Similarly, if you have something like x to the power of 8 is less than x to the power of 7, we'll deal with how to solve such equations later. But how would you set it up? You would say x to the power of 8 minus x to the power of 7 is less than 0. I wouldn't take x to the power of 7 out common from the outset. I would try to make the equation more simplistic. I would remove x to the power of 6 common and write that as x square minus x is less than 0. And by taking out x to the power of 6 common, I know that's always going to be positive. So I can ignore that entire term. So everything in this equation, or the analysis of this equation, will depend upon x square minus x being less than 0, or x into x minus 1 being less than 0. Now, how to solve this, we'll look at a little later. But I'm just focusing here on how do you set up equations such that they are conducive to analysis. So remember, when you're working with equations, always use 3 golden rules to set up equations conducive to analysis. What do you do in the 3 golden rules? Keep the right hand side 0, factor the left hand side into a product or a division of values, always factor out even powered terms. You see an opportunity to factor out in even powered terms, you can get rid of it, take that opportunity, right? And then what do you do? After you set things up using the 3 golden rules, you're always going to analyze. You're going to analyze the given equation based on sign. Sign analysis always takes dominance. And then based on magnitude. So this 3 golden rules always simplify your equation for you, which makes your analysis a lot more effective, a lot more easier to work with. So whenever you're working with an inequality question, don't dive right in and try to analyze. Remember, it's always a mixture of algebra and analysis. Algebra should always come first. The algebra bit is used for you to set up the equation such that it becomes easier for you to analyze. So the 3 golden rules will help you set things up. Once you've simplified your equation, you've set it up the way it's supposed to be done, at that point, I would go into analyzing based on sign and based on magnitude. Okay. So quick recap. I'm just going into, yeah. So remember the 4 fundamental rules. what you can do, what you cannot do. Rule 4 is important. You can never multiply or divide with a variable until you know the sign of the variable. If you know the sign, it's great information to have. You can always, it opens up the possibility for you to manipulate using multiplication and division. Also, remember the basics of algebra comes into play. So if you need maybe a refresher on the basics, a refresher on the guidelines of algebra, please go ahead and look at the algebra video that's already on YouTube. It's almost 2 weeks back that the session was done. Good session. There's also a PDF that you can download with everything summarized and the questions solved. And remember the most important bit: approach an inequality question using an algebra and analysis mindset. Set up the question conducive to analysis using the 3 golden rules. Analyze based on sign, based on magnitude. Stay within the purview of the rules. And remember, simple rule of algebra is work towards the question and then try to reason out your answer. Got it? Now, what do I mean by this? Let's put this into practice. I'm going to take some examples, right, where I'm going to give you some equations. So let's take the first example. And I want all of you all to give a shot at trying to break it down and make it conducive to analysis. So let's take an equation. 1 by r plus s is less than 1 by r plus s, where r plus s is not equal to 0 and r is not equal to 0. So I want all of you all to try simplifying this equation and setting it up using the 3 golden rules. Give it a shot, please. I'll give you all maybe 20 seconds for it. Remember what I said. Keep the right-hand side 0. Make the left-hand side a product or a division of values. And if there is an opportunity for you to remove an even power term, factor it out and ignore it. I don't expect you to type the entire expression. I'm not asking you to solve anything, guys. All I'm asking you to do is I want you all to focus on setting up this given equation such that it becomes conducive to analysis, right? So again, let's do it together. Always keep the right-hand side 0. So I'm going to take whatever is on the left-hand side to the right-hand side. Let me take the LCM first. So this is r, and this is going to be 1 plus rs. I'm going to pull everything to the left-hand side. So 1 divided by r plus s minus 1 plus rs by r is less than 0. See, at this point, I cannot multiply and divide because I don't know the sign of any of the variables. Okay, so I'm not going with multiplication and division because I'm unsure about the sign. So I'm sticking to basic principles. I can manipulate using addition and subtraction. Now, I see that there's a subtraction of terms here, and the right-hand side is less than 0. I would want to make the left-hand side into a product or a division of values. So r times r plus s. So I'll get r minus r plus s into 1 plus rs is less than 0. I can open up the numerator because I think some terms will cancel out. So r minus r minus r square s minus s minus rs square divided by r into r plus s is less than 0. See, I'm setting it up. I'm setting it up as a division. So here r cancels out. I'm left with minus r square s minus s minus rs square divided by r into r plus s is less than 0. And I see s is common. I want to make things into a product. So I'll pull out a minus s common. So I'm going to be left with r square plus 1 plus rs divided by r into r plus s is less than 0. Now my equation is conducive to analysis because for this division of terms. You see, I have boiled everything down to a division of values. For this division of terms to be less than 0, I know the signs of the numerator and denominator have to be opposite signs, right? It has to be opposite signs. So based on any extra information that the question provides, I can then use this equation to run my analysis. Because if I keep things in terms of products and divisions, it becomes easier for me to analyze. Okay, so the first instinct that you should have is not just dive right in, right? Whenever you see equations that can be broken down, that can be simplified, use algebra and the three golden rules to set things up. You would want an equation like this to analyze. Why? Because it's going to be easier for you to analyze based on sign first. Got it? Okay. Let's take another example. And I want you all to give me an answer to this. Okay. My question is solve for x. I want you all to give me what would be the different solutions for x in this given equation. And to be very truthful, I don't even think you'll have to write anything down and work with it. If you're going to use your analytical abilities to work, observe the equation that I'm giving you. Look at what is special about it. Look at the inequality entirely. Don't dive right into the calculations. And then try to reason out your answer. Okay? X minus 4 to the power of 4 into x plus 5 to the power of 6 divided by x minus 2 to the power of 10 is less than or equal to 0. So what I want an answer here this time, okay? I want you all to analyze this question. Don't open it up, don't work with it. Look at the equation. Look at what you have on the left-hand side. Look at the right-hand side. And then tell me what values of x would satisfy this given equation. Very good. Good. I see some of you all giving an answer. Remember, guys, don't get into calculations, right? It's all about analysis and all about thinking about the three golden rules. Remember, I said it's a boon when you have even powered terms because they're always going to be positive, right? Okay, so looking at this entire equation, I have a numerator, I have a denominator, I have the right-hand side 0. It's perfect for analysis, right? The right-hand side is by default 0 and the left-hand side is a product or a division of values. On top of that, if I look at it a little more carefully, every term is raised to an even power. So if every term is raised to an even power, any even powered term is always going to be either 0 or positive. But they're asking me for solutions where this entire left-hand side is less than or equal to 0. Now, I know this term is going to be 0 or positive. I know this term is going to be 0 or positive. I know this term can be 0 or positive. But I cannot have 0 on the denominator because if anything divided by 0 is undefined, so I know my denominator is positive. So it's impossible for me to get an output which is less than 0. So what is the next best thing I can do? I can have it to be equal to 0. And when will this entire left-hand side be equal to 0? When the numerator is 0. And what values of x will make my numerator 0? X is equal to 4 or x is equal to minus 5. I'm not going to take x is equal to 2 as a solution to this equation. Why? Because if I take x is equal to 2, my denominator becomes 0. And I cannot have the denominator to be 0 because something divided by 0 is undefined. So you see what I'm asking you to do? I'm asking you to look at the equation, observe the equations, and then try to analyze out of it. If the equations are, this equation was very easy for me to analyze because it was already set up using the three golden rules. The right-hand side was 0 and the left-hand side was a product or a division of values. If you don't have an equation set up like this, then it becomes more difficult for you to analyze. So your first instinct should be, can I break down the equation and set it up such that it is conducive to analysis using the three golden rules? And then once I simplify everything, can I analyze, based on the equation that I have? Got it? Any doubts? Okay, let's try one more. And again, I want you to look at it from an analytical perspective. And this time I'm going to give you some additional information. Okay. X and Y are positive integers. I'm giving you this. And remember, what is the immediately when you see X and Y are positive integers, what should be the thought in your mind? It opens up the possibility for me to manipulate with these variables, right? With multiplication and division specifically. And now I'm giving you 2 plus x divided by 3 plus y is greater than 2 plus y divided by 3 plus x. So I want all of you all to try to simplify this equation. Try to use the information to your advantage. And then tell me what is the inference that you can draw when you break down this entire equation. Okay, I'll give you 30 seconds. Give it a shot. Okay, I see 3 of you have already broken it down well. I want everyone else to try it out, please. Use the information to your advantage, right? And then see what is the way you can manipulate. If not, stick to basic principles. So keep the right hand side 0, the left hand side as a product or a division, and then try to simplify. Okay. Now, what I observe here is I know the signs of x and y. Immediately, when I see that I know the signs of x and y, I know I can manipulate with multiplication and division with x and y. And if I observe the given equation, I have 2 plus x divided by 3 plus y and 2 plus y divided by 3 plus x. And since I know x and y are positive integers, this numerator is positive. This is also positive. This numerator here is positive. This is also positive. So basically, all the terms on the numerator, the denominator are positive. And since that's the case, I can manipulate using multiplication and division. And this is why these kinds of information are very crucial towards working. So if I cross multiply, I'm going to get 2 plus x into 3 plus x is greater than 2 plus y into 3 plus y. I can cross multiply, absolutely fine. Right? Why? Because all the terms are positive. Now I can open it up. So I'm going to get 6 plus 2x plus 3x plus x square is greater than 6 plus 2y plus 3y plus y square. So x square plus 5x plus 6 is greater than y square plus 5y plus 6 as well. I can cancel out the 6 on both sides. Remember what I said, always keep the right hand side 0. The left hand side should be a product or a division of values. So I'm going to pull everything to the left hand side. 5x minus y square minus 5y is greater than 0. And this is something we discussed in the algebra session. Whenever you have terms like this, you need to regroup the terms and try to factor things out into products or divisions. So it's better for me to write this as x square minus y square plus 5x minus 5y is greater than 0. X square minus y square is x minus y times x plus y plus 5 into x minus y is greater than 0. So I can pull out the x minus y common, and I have x plus y plus 5 is greater than 0. Now this is the equation that I have. I have the right hand side 0. I have the left hand side as a product or a division of values. Now it's easy for me to analyze. I know if a product of two terms should be greater than 0, then both the terms have to be positive or both the terms have to be negative. But what do I have in the constraints? I have x and y to be positive integers. So if x and y are going to be positive integers, then x plus y would also be a positive integer. And x plus y plus 5, that entire term is going to be positive. And if this entire term is positive, then x minus y also has to be positive. So the inference that I can draw here is that x minus y is greater than 0, that is x is greater than y, right? And now, right, boiling this equation down to this form is actually going to be useful for me, because as I go further, whatever the question asks me, it's going to be very easy for me to link it to this information and break down the question and work with it. Got it? So remember, it's very important when you're working with inequalities to use an algebra and analysis process. Algebra is one that takes priority because it sets things up for you to analyze, right? 3 golden rules to set things up. Got it? Okay, so let's look at some questions. Before we look at some questions as well, we have a, like I've been taking sessions on quant, we have your verbal sessions also starting, right? And the infamous Marty Murray is taking up those sessions. He's a GMAT 805 tutor. I mean, fantastic score, fantastic sessions. I myself look at his videos a lot of times. The session is scheduled tomorrow at 9 p.m. It's on CR, and it's a session where you're going to master CR in 7 days. Don't miss the session, guys. Right? So ensure that you attend the session tomorrow, and I hope it's definitely going to be useful. Right? Okay. So let's look at the first question. I'm starting with an easy one. Remember what I said? Hold on to your constraints. Look at the equation. Don't dive right in by putting in values. Think of an algebra analysis process. Use algebra to break it down. Simplify. Set it up. Then analyze. Then pick your answer. I'm going to give you all maximum of a minute. That's how much time this question should take. Your time starts now. Predicted, I mean, I if there are addition of terms, right, on both sides of an equality, I can't divide both sides. If I have something like a plus 2 is equal to b plus 4, I can't divide both sides by b, one single term, right? So it's always best to take things to the left hand side using addition or subtraction and keep the right hand side 0. Dividing both sides also requires you to know that it's that term that you're dividing with is not equal to 0, right? That's why I think that's why I mentioned about the algebra session as well, right? I cater to why you should never multiply and divide with a variable even when you work with an equality, right? I suggest for you to look at that video as well. Okay, you can start typing your answers in the chat window, please. Okay, started with an easy one. Remember, the mindset that I want you to develop is an algebra and analysis mindset, right? So what have we been given here? A is greater than minus 1, and I have 1 by a square plus 1 by a square minus 4 is equal to 0. Gives me an opportunity to break things down here. So I will take the LCM, a square into a square minus 4, and I have a square minus 4 plus a square is equal to 0. The good thing is the right hand side is an equality, so it becomes easier for me to work with. I can multiply both sides by a square minus 4. So a square to a square minus 4 is equal to 0. So 2a square is equal to 4. So a square is equal to plus or minus 2. For those of you who were not getting the answer, right, this would have been your mistake, right? You wouldn't have put the plus and minus possibility. Let me do it step by step. So 2a square is equal to 4. So a square is equal to 2. So at this point, you all would have written that a is equal to a plus root 2 rather than considering both the plus and minus possibilities, right? So a is equal to plus or minus root 2 is what you would get at this point, right? Now, if a is plus or minus root 2, a has two possibilities. A can be a plus root 2 or a can be a minus root 2. Remember, root 2 value is approximately a 1.414. And this is 1.414. And I have this as minus 1.414. But what is the constraint that I've been given? A is greater than minus 1. Minus 1.414 is lesser than minus 1. So this is a solution that I'll have to discard because it violates the constraint that is given, right? So A has to be 1.414, and the questions ask me A lies between which of the following has to be 1 and 2, right? Very simple one to start with. Touches upon the fundamentals of algebra, touches upon how you use your constraint into, how you take your constraint into consideration, how you simplify an equation, and how you break it down, and how you work. What shouldn't be your process of working is take a value for A and start putting it into this equation. It'll be very difficult for you to be able to pick the root 2 possibility. If you're good with numbers, you can, but root 2 possibility for you to see that it satisfies this given equation. So remember, algebra and analysis always stays priority. It's an equality, right? I mean, if it's an equality, I can just multiply both sides by a square into a square minus 4, right? Think about it, no? If a is greater than minus 1, if a is greater than minus 1, then a square is always going to be a value that is more than 0, correct? Think about it, guys. Okay, if a square is greater than minus 1, right? If a is greater than minus 1, the values of a would be minus 1 onwards to plus infinity. So if I square it, it can be 0 or positive, right? So when I have an equality of 0 on the right hand side, I can just take it. It's like this, right? If x by y is equal to 0, the only way that this is going to be equal to 0 if is my numerator is 0, correct? My denominator I can just ignore. For any fraction, for any division of two terms to be equal to 0, my numerator has to be 0. So what I'm basically doing here is I'm saying if this is my fraction, my numerator is what? 2a square minus 4, and that has to be equal to 0. Okay, so Varun says, I have a doubt. Let's say we have x in the denominator and the other side of the inequality is 0. We do not know the sign of x. How can I take x to the other side and the RSS still stays 0? I'm giving you an example, Varun. So x by y, if I give you equal to 0, right? This is not an inequality, right? This is not an inequality. This is an equality here. The equation did not have an inequality. So when I give you a fraction x by y is equal to 0, how can this fraction be equal to 0 if my numerator is 0? Correct? So the only condition that I'm worried about here is the numerator being 0. It doesn't matter what the denominator is. The denominator should not be equal to 0. That's the most important bit. Right? The denominator should not be equal to 0 because something divided by 0 is undefined. But if I have something like x by y is greater than 0, then obviously I cannot multiply both sides by y, right? Because I'm unsure about the sign of y, right? This was an equality, right? This is an inequality. So here, if x by y is greater than 0, I would just say that both x and y are positive or both x and y are negative. Make sense? So if I have an equal to 0, right, I'm just using simple fractions, right? If I want a fraction to be equal to 0, my numerator has to be 0. Simple as that. Got it, Nikhil? It's an equality. That's what I'm saying, right? For those of you all who have this doubt, I think it's important that you look through the algebra session as well, where I put in the ground rules of what to do with equality. I gave you an example, right? If I work with an inequality, x by y is greater than 0, without knowing the sign of y, I cannot do it. Correct? So if I give you x by y is greater than 0, all I'll do is I'll say both x and y should be positive or both x and y need to be negative. Right? I cannot say x is greater than 0. This would be wrong. Okay? But this was an equality, so I didn't need to worry about it too much. Makes sense? With inequalities, different rules apply. With multiplication and division, you have to be slightly careful with it. All right? Okay. Here's question 2. I'm going to slowly increase the difficulty level. So give it a shot. Again, a minute to try solving this. Remember, what I'm asking you to do is I'm asking you to develop a mentality of using the information given to your advantage, trying to manipulate using algebra, try to set things up conducive to analysis, and then work towards the question. If you do it the right way, you would get your answer in 20 seconds here. All right? So, yes, Bhumi, the square root of any positive integer is always positive. Again, guys, for those of you who are asking me about the equality and the square root, I've taken care of all of this in the algebra session. Okay. Okay. Seem to be getting in a lot of answers. We have almost 60 people in the stream, guys. I would want an answer from everyone. It's okay even if you don't get it, but give it a shot. Try to avoid, that instinct of plugging in values. Think about how to use the information to your advantage. How can you break things down? Good. I think most of y'all are getting up to speed on that aspect. So let's break it down, right? I told you whenever you get information about the sign of a variable, it's a boon to you. and they've given me y is less than 0. As soon as I see that, I know I can manipulate my equation with multiplication and division with y. And I've also been given that 4x is greater than y. And the questions ask me which of the following could be equal to x by y. Remember the simple rule of algebra. Work towards what the question's asking. Manipulate within the rules of inequalities. Work towards the question. Since I need x by y, and I know y is less than 0, I can divide both sides by y, right? I can say divided by y, divided by y. But since I'm dividing both sides with a negative number, I can flip the inequality sign. So 4x by y is less than 1. I'm flipping the sign. And I can divide both sides by a positive 4. That's not going to change anything for me. So x by y is less than 1 by 4, right? So if x by y is less than 1 by 4, this is what I end up getting. The questions ask me which of the following could be equal to x by y. So I need an answer choice that is less than 1 by 4. And there's only one possibility that's less than 1 by 4. B is equal to 1 by 4. Everything else is greater than 1 by 4. A is the only possible answer choice. All right. Okay. Any doubts here? Very simple to start off with. Two simple questions gets you up to speed into thinking from an algebra and analysis standpoint. The next question is going to challenge you all a bit. I'm going to introduce you to what kind of questions are very prevalent on number properties and statistics and in inequalities, and that's the must be and the could be kind. Right? Any doubts before we move forward here? Right? No? Okay, so here's the third question. A tricky one. I'm going to use this question as a blueprint to put in a process of how you work with a must be question. Right? I want all of you all to give a shot at it first. Right? I'm going to give you all the full 2 minutes here, and then we'll have an in-depth discussion. Give it a shot. Okay, you can start typing your answers in the chat window, please. but I added the values in the options. Okay. Okay. It's a very good question, okay, and it's a good question that you can learn from, because the way you have to approach must be true questions is very similar to the way you approach critical reasoning in verbal. Okay. I see most of y'all have given me B. There have been some C's as well, right? So all of y'all are picking between B and C. Let's look at it, right? I'm going to first given put in some sort of theory here, especially in terms of how to approach must be true questions. It's going to be very difficult for people who are using values to work with such a question. Very difficult. I wouldn't even suggest for you to use it, because there's no limitations on what values you can take for A and B, right? So if you went that route, then you need to rethink and integrate what we discussed in the first bit of the session. For those who manipulated it algebraically, good for you. I think that's the first step. But then the analytical bit is where you have to be slightly careful. It can be E as well. Okay. um okay, let's see. You can't have more than one answer choice, obviously. Now, what is the meaning of must be true? Let's understand this first. Okay. What is must be true? It should always be true for every, whatever statement you're picking as true should always be true for every possible value within the constraint. Whatever you pick as your answer in a must be true scenario should always be true within, for every possible value within what the constraint has defined. And if it's a must be false, I'll explain what do I mean by the constraint. If it's a must be false, it has to be always false, or basically it should be never true for whatever values you take. Regardless of any value, it should be never true. This is a very important distinction that you have to have. In a must be true scenario, you need to pick an answer choice that caters to every possible value that the constraint of the question is defining. That's the important bit. You need to pick an answer choice that caters to every possible value within the constraint that is defined in the question. So what do I mean by that? Let's look at this. What have I been given? A plus B is less than 0 and A plus 2B is equal to 3. I'm going to write them down. And they ask me which of the following must be true. And just doing a vertical scan in my answer choices here, I see that everything relates to A. So immediately that should be a hint to you that I should be trying to manipulate these two equations and try to make A the subject of my entire manipulation. Because if I manipulate these two and keep A as the subject, it becomes easier for me to work with my answer choices. I can't substitute an inequality into an equality. It's never good to do that, right? So I can do the reverse. I can always substitute an equality into an inequality. And I want to make A the subject of my manipulation, right? So I'll say 2B is equal to 3 minus A. So B is equal to 3 minus A divided by 2. And I can take this and I can substitute that into my first equation. So A plus 3 minus A by 2 should be less than 0. 2A plus 3 minus A by 2 is less than 0. So A plus 3 is less than 0. I'm just multiplying both sides by 2 to get rid of the 2. So A is less than minus 3. This is what the question constraint gives me. So what is the question actually? If a is less than minus 3, remember this is a constraint. Any constraint that is given to you in a question has to be respected. That means if I say a is less than minus 3, the only values of a you can consider in this question are values less than minus 3. And they are asking me now, if a is less than minus 3, which of the following answer choices must be true? And what did I say we should do in a must be true scenario? I need an answer choice. There are two ways you can look at it. The first way you can look at it is you need an answer choice that caters to all the defined values of A, right? I need an answer choice that is always true for every possible value within the constraint. So I need an answer choice to cater to all the possible values I can consider for A. So I look at answer choice alpha. Answer choice alpha gives me A greater than 4. Greater than 4 doesn't even cater to even one value of what the constraint is given. So I knock off A. Most of y'all picked B, which would be the trap answer here. A is less than minus 4. A is less than minus 4 does not cater to all the possible values that the constraint gives you, because it doesn't cater to the values between minus 3 and minus 4. So that cannot be true always, because it doesn't take care of every given value that the constraint defines. I remove B. A is less than minus 2. A is less than minus 2 will cater to every possible value that my constraint defines. It takes care of all the possible values of A which are less than minus 3. C would be my answer. Very tricky concept for you to understand. Now, obviously, your doubt will be, Aditya, A is less than minus 2. How can you take? Because you can have A is equal to minus 2.5 also. Then I will tell you, if you have this doubt in your head that A can also be equal to minus 2.5, I would tell you that A is equal to minus 2.5 is something I cannot even consider in this question, because they have given me a constraint that the only values I can consider for A should be less than minus 3. So what did I say? What did I say should be your approach in a must be true question? In any must be true question, you need an answer choice which is always true. It should always be true for every possible value. For every possible value within the constraint. And if you look at it, A is less than minus 2 takes care of every possible value within the constraint, right? So A is less than minus 2 is definitely true. That's one way to look at it. Another way to look at it when you work with a must be true question is to try to disprove, right? It's like similar to your negation process in critical reasoning. What do you do? If you want to prove something to be true, you negate that statement. And if you negate the statement, staying within the purview of the limitations that the question provides, if you negate it, and if it breaks the argument, then you know that has to be true. But if you negate it and it satisfies the argument, then you know that cannot be true always. So if I look at A greater than 4, that's obviously not going to, be less than minus 3. But if I take A is less than minus 4, I will say, okay, what if A is equal to, say, minus 3.5? See, let's take another value here. A is less than minus 4. So I have A to be less than minus 3, right? What does this answer choice give me? A should be less than minus 4. What if I have a value of A is equal to minus 3.5? Minus 3.5 is definitely a possible value that the constraint provides. Does A less than minus 4 cater to this value? Definitely not. So should A always be less than 4? No. But if I take A should be less than minus 2, if I look at it, if I try to negate it, I'll say I can keep A is equal to minus 2. But a is equal to -2 is something I cannot even consider because it breaks my argument. It breaks the constraint. And if I say a is greater than -2, that also would break my constraint, right? Because it doesn't satisfy the constraint that is given. So C has to be my pick. 2 is less than a less than 4 obviously is not a possibility. Can we not add b on both sides of the inequality and get b is greater than 3? You can if you want to do that, right? You can manipulate with b. The reason I didn't do that, Srivadas, is because think about it. Now I'll always work towards what my question is asking me, right? All the answer choices were giving me information about a. So I manipulated my equation to get a, right? Because I saw that I had a in all of my possibilities. You can still solve for b and then substitute that to get for a. That is also absolutely fine, right? Okay, but guys, why C is your answer and not B? There's two ways to look at it. One way to look at it is whenever you see a must be true question, what is the rule? You need to pick an answer choice that satisfies or caters to every possible value that the constraint defines. Or disprove. Try to negate the answer choices and try to see, is it possible for me to have a value that goes against this but still satisfies my constraint? If it does, I can eliminate it. Now, obviously, questions will be, why can't I take a is equal to -2.5? I cannot consider a is equal to -2.5, guys, because the constraint is a is less than -3. What are the only values that the question defines for a? It tells me that a should be less than -3. That is why I cannot consider a -2.5. It's like this, right? If I give you a constraint in a question, if x is an integer, if I give you a constraint, if x is an integer, can you consider x is equal to half? Definitely not, right? Because I have to respect the limitation. What was the limitation here? The limitation, when you broke down the equation, the limitation that you got was a is less than -3. So the only values of a that I can consider in this question are values less than -3. And I need an answer choice. Look at it like that. I need an answer choice that caters to all of these values in the limitation. The only answer choice that will cater to every single value of the limitation is a is less than -2, right? Because numbers, yes, Vishal. So a is less than -4, right? Will it cater to -3.5? Will it cater to -3.5? -3.5 is also a possible value, right, of a. So if I tell you that a can be equal to -3.5, then it will just eliminate your possibility, right? A can't be. Remember, this is a must be scenario. So you are telling me a should always be less than -4, but that's not the case, right? A can also be equal to -3.5 because -3.5 is a constraint that the question provides, correct? For option C, we can take a is equal to -3. Absolutely fine. You can take a is equal to -3. Right, and that is also a way to negate it, right? As I would negate it by just changing the sign to an equality or an inequality, right? What about a is equal to -3? Okay, again, coming back to your question, guys, what is the constraint here? All of you also, you'll have to wrap your head around the constraint. What is the constraint that the question provides? The constraint is if x is an integer. So your question is, if I give you x is an integer, I can consider half. Can I consider half? No. So if the constraint is telling me if a is less than -3, you're telling me I can consider a is equal to -3. I cannot consider a is equal to -3 because it violates the constraint that is given. Yes. That is what I meant, Varun, right? That when you cannot take a is less than -4 because it doesn't cater to all the values between -3 and -4, which are defined values for a. And that is why I wrote this down, right? You can only pick an answer choice, right? When, especially in a must be true question, you can only pick an answer choice that is always true for every possible value within the constraint. So you need an answer choice that satisfies every possible value within the constraint. For people asking me why it cannot be -2.5 and why it cannot be -3, because the constraint tells me a is less than -3. Remember, it's like your critical reasoning question. any information that is given in the argument is definite information, right? When you have facts that are given to you in an argument, you can't go against those facts. A is less than minus 3 is a fact that the question defines. Staying within the limitation of that fact, I need to figure out which answer choice gives me all those possibilities. Got it? I have nothing to do with B, guys. Here, my entire analysis is based on A. Why would I want to go for B? The question is asking me about all my answer choices are about A, whether A is greater than 4, A is less than minus 4, A is less than minus 2, or A is between 2 and 4. So I don't need to worry about B, and that's the first step that I did, right? I boiled it down. I boiled down my equation to represent what A is. Got it? Khyati, I think your understanding of, you know, if they're not given me an integer, I never considered integers, right? Minus 3.5 is not an integer, right? Minus 4.7 is not an integer, right? So yes, I can consider all real numbers, right? I can consider all real numbers. Even roots are a possibility. So the point I'm making is I cannot take less than minus 4 as a possibility because it doesn't cater to all the terms between minus 3 and minus 4. Nowhere have they told me it's an integer, right? So I can have also A to be a minus 3.1, minus 3.5, and so on. Yes. If you draw a number line, you'll understand it better. But think about it, guys. You don't need to draw a number line to work with it. The point I'm making is look at it as a critical reasoning question. If I've been given a constraint, I have to respect that constraint. I need an answer choice that caters to all the possible values of that constraint. Got it? Yeah, that's normally the case, right? Because you didn't run through your possibilities. Remember, what you have to do when you have a must be true question is always the run through the possibilities. I've written the steps here. Okay, you don't need to write it down, but remember, when you have a must be true question, you should pick an answer choice that is always true for every possible value within the constraint, right? So what do? You understand the constraint, you work with the constraint, you simplify, and then the second bit, Sivadas, is you have to run through the answer choices and see which of these answer choices caters to all the possible values that you have. Okay? Plugging in would be a very, very difficult approach here because of no limitations. Like somebody correctly mentioned, I can have any real numbers for X that I can pick. Smithy, I told you, right? I cannot consider minus 2.5 because the condition, I mean, all of you all need to, think about this like a data sufficiency question, right? If A is less than minus 3, this is what the question is. If A is less than minus 3, that means the only possibilities that I can consider for A should be less than minus 3. Then which of the following must be true? Now, if people are saying, why can't I consider minus 2.5? Because if I consider minus 2.5, it will violate my constraint. So I cannot consider minus 2.5. All the other values that I can consider based on my limitation will cater to all the possible values that are defined for A. Right? So what is this? If somebody said you can draw the number line, so I'll do it. This is minus 2 and this is minus 3. These are all the legitimate values that you can consider for A. This. Answer choice C gives me this entire thing. I cannot consider these values between minus 2 and minus 3 because the constraint doesn't define that. So if I don't consider this, I cannot consider this region because it violates my constraint. What are all the other numbers that I can consider? The other numbers I can consider in this range would be all values from minus 3 onwards to minus infinity. So this answer choice caters to every value that my constraint defines. Correct. Very tricky question type. It will take you some time to get accustomed to working with this, but it's a very critical reasoning approach towards working this, right? And you're going to get a lot of questions on must be truths, especially on topics of inequalities, absolute values, number properties, and statistics. This process will always hold good. You have to pick an answer choice that satisfies all the limitations, right? Okay. All right. But in some cases, right, in some cases, you may not be able to use and break down algebraic equations. And that's the only time I would think about plugging in values. When would I plug in values? Only when the algebra and analysis process completely fails me. And you will see, once you see an equation and you know there's absolutely no scope for you to break it down, you're left with no other option than to put in values. When you're putting in values in any must be question or any inequality question, remember first, again, I have to pick values that satisfy what the constraint is giving me. And based on the constraint, my advice, whenever you're putting values in an inequality question, draw a number line. Based on the constraint, test for extreme values within these regions. Okay, test for extreme values within these regions. And when you're putting in values, you should always have a negative mentality. You should not put in values to try to prove. Instead, you should try to put in values to try to disprove. That's what we call a counter example, right? In a must be question, I would always try to disprove. But if I'm working with a could be question, a could be true, I will always try to prove. Remember, that should be your entire approach. In a must be question, I have to try to disprove, or I have to ensure I pick an answer choice that caters to every limitation that is defined in the question. Could be true questions are slightly more easier. Could be true question means I just have to prove one possibility, get to one possibility. Same you would do when you have a could be false as well. Try to prove one case which is false, right? But how do you put in values? What is the best way? I told you one best way of working with values is, especially in inequalities, is to put in the number line, put in -1, 0, +1, and test for extreme possibilities. But sometimes the question will give you certain patterns that you can use to your advantage. For example, if I have even powered terms, right? When I have even powered terms given to me, that should be, say a trigger that tells you that I should also think of negative possibilities, right? Because negative possibilities will also, satisfy even power terms, because a negative whole squared or negative, to the power of 4 will also give me a positive value. Or if I see any expression getting reversed, right, then I would think about fractions. Now, what do I mean by this? Let's take an example. Okay, let me just shift to the sketchbook. So let's consider values of x greater than 1. Okay, I'm asking you to consider all values of x from 1 onwards to infinity, non-inclusive of 1. So my question to you is, if I consider all values from 1 onwards to infinity, if I take that value x, I square it, I cube it, out of these three, x, x square, x cube, which would be the greatest and which would be the least? So if I give you x is greater than 1, right, and I take that value x, I square it and I cube it. Out of these three quantities, which would be the greatest and which would be the least? X would be the greatest. Think about it. Now take a number, right? I mean, it's absolutely fine to take a number. So if I take 2, I'll get 2 square, I'll get 2. Take 1.1 as well, right? So if I have x is greater than 1, then the general relationship will be x cube is greater than x square is greater than x. But what if I take a value between 0 and 1? Let's say I consider all values between 0 and 1. And again, I take x square, I take x cube. So if I give you the range between 0 and 1, what would be the relationship between x square and x cube? Which would be the greatest and which would be the least? X is the greatest? No, 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 no. Guys, don't rush through. See, whenever you're in doubt, put in a value. Okay, I'll give you one more. Root of x. Okay. X is the greatest if I keep it as it is. What if I give you root of x as well? And cube root of x. So I'm giving you x's between 0 and 1. And I'm asking you to compare the cube root of x, the root of x, x square, and x cube. Out of these five, which would be the greatest and which would be the least? Cube root of x is the greatest, right? X is least and x cube is the greatest. If I give you only x square, and x cube, that would not be the case as well, right? Think about it, guys. Take a value. Take x is equal to, say, let's say 1 by 4, right? X square would be 1 by 16. X cube would be 1 by 64. This would be half, and this would be the 1 divided by cube root of 4. A cube root of 4 would be around 1.7 something something something. So clearly, if I take if I take a fraction and I square it and I cube it, the denominator becomes larger. So obviously the fraction reduces, but if I root it, the denominator becomes smaller. So the value increases. So the greatest here would be the cube root of x, and the least would be x cube, right? So whenever you're dealing with the range of 0 to 1, things reverse. Normal order reverses. You're going to get the cube root of x to be greater than x, greater than root of x, greater than x, greater than x square, greater than x cube, right? So normally within the range of 0 to 1, your relationships reverse. So if you see suddenly relationships reversing, you know that that's a trigger that I have to think about putting in fractions and working. Got it? All right. So understand how, the square, the cube, the square root, and the cube root works within the range of greater than 1 and between 0 and 1. The reason I'm not taking negatives is because I'm using the root and the cube root as well, right? So, I'm not taking that because the root of a negative number is imaginary. We don't deal with imaginary numbers, right? So remember this, guys. Whenever you deal with a range of 0 to 1, normal, relationships reverse. Okay. So whenever you work with a could be true question, I want you to think about finding a case which is true. And I told you, whenever you're not able to work with an algebra and analysis process, you're forced to plug in values. Plugging in should be the way you employ the process you employ, but you'll have to be smart with the values you work. A could be true question, you should always pick values to prove something to be true or prove something to be false. Okay, let's try another question. Tricky one. Give it a shot. For those who are putting in answers in the chat window, remember, guys, two things. The constraint that the question provides should never be violated. If you're using values, you have to pick values that satisfies your constraint and then also the equation that you've picked, right? So if you're eliminating something, you're telling me that that cannot be true at all, right? Varun, the session is going to go on for maybe an hour more, right? So there's something more to cover, right? As I told you, it's going to be, you're in for the long haul here. I'm going to try to exhaust whatever is required for this topic. So if you feel that, it's a long day for you, you can always look up the recording the next day. Okay, I'll be providing, the recording will be uploaded. Plus, I'll be giving you a PDF of the slides as well. For those who are giving me C as the answer, so you all should tell me how did you eliminate 2, right? For those giving me B as the answer, you should tell me how you eliminated 3. Remember, guys, my job is to try to pick values that stays within the purview of the constraints and try to prove each of them to be true. Z cannot be greater than Y. Why not? Have you thought about fractions? That's why I said, guys, always think about all kinds of values. And that's the downside towards plugging in. And this question, you're forced to do that. Need not be only fractions, Sweta. Nowhere has the question told you that it's fractions. Why I cannot have integer values that can also be in that form? I mean, I can just pick immediate values, no? X is 2, Y is 1, Z is 0, right? 2, 1, 0. 2, 1 square is 1, 0 square is 0. 0 to the power of 4 is 0. So that is also satisfying, right? I can't make such assumptions, right? It doesn't mean that if something is greater than a square and greater than a power of 4, that it only has to be in fractions, right? That's not a valid assumption. For 2, take x equal to root 2. Guys, you don't need to pick such weird values, but that is a good attempt, right? At least you're thinking out of the box, I would say, right? Think about fractions, right? The question gives you a clue. The problem that most of you all, are facing here is you're randomly picking values, and you're thinking, okay, I have to exhaust this possibility, this possibility. No, look at the pattern, right? Look at the pattern of the first answer, first inequality. What is happening in the second? It's reversing. So in the first, you have x is greater than y greater than z, and the second is z greater than y greater than x. The entire inequality is reversing. So normally, whenever things reverse, no, it should immediately strike that, okay, I may have to put fractions and work with here. What is the rule for a could be true question? You should try to find one case which is true. But what is the most important bit? I have to stay within the limitations of the constraint. I have to stay within the limitations. So I've been given x is greater than y square is greater than z to the power of 4. I cannot violate that. And I need to first evaluate 1, x is greater than y greater than z. Now this is very easy for me to do, right? I can immediately pick some nice integer values and work with it. So I can take x is equal to 2, take the simplest I can. Why? Remember, I just need to prove one case which is true. I'll take the simplest value I can. X is equal to 2, y is equal to 1, z is equal to 0. They've not put any limitation. Don't be afraid to use 0 and 1. They're good options for you to work. So x is equal to 2, y is equal to 1, z is equal to 0. 2 is definitely greater than 1, is definitely greater than 0. So the values I've picked are satisfying my limitation. And the values I've picked are also satisfying the first statement. So I know 2, 1, and 0 definitely satisfies the first. So I know 1 has to be a part of my answer choices. So D goes away. Second, Z is less than, let me put it this way, right? Let me put it on this side. So it becomes easier for you to process. Second, Z is less than Y is less than X. As soon as I see the first thing when I used integers, it's satisfied, right? X was greater than Y greater than Z. But suddenly they're reversing that relationship. Anytime I see that the relationship has been reversed, right? Immediately I'll think, okay, maybe fractions might reverse the relationship that I've proven in the first case. So what will I do? I'll have to pick values first to satisfy fraction values to satisfy my constraint, and then see whether z is greater than y is greater than x. I want to take values, I want to take fractions where z is greater than y greater than x, and also values that satisfies my constraint. So I'm going to keep something like x is equal to, let's say, a 1 by 5. Y is equal to, remember I'm squaring, right? So if I square it, the value of the fraction reduces 1 by 3. And I can take z is equal to 1 by 2. Say I want z to be the greatest, right? So 1 by 2 I know is the greatest, 1 by 3 is next, x is 1 by 5. Does it satisfy the constraint 1 by 5? Is greater than 1 by 9 for sure. Is greater than 1 by 16, right? So I know that z is greater than y is greater than x. Half is bigger than 1 by 3 is bigger than 1 by 5. So I can definitely prove this as well. 2 works out. So 1 and 2 is definitely a possibility, right? It cannot be 1 only. It cannot be 1 and 3. And finally, the third one, x is greater than z is greater than y. They're reversing z and y. You see, I have in the first case when I used integers, x was greater than y is greater than z. They're reversing z and y. So maybe for z and y, I need to think about some fractions. For x, I can keep some sort of integer. That's not a problem at all. So I can keep x as like 10. I can keep y as, let's say, 1 by 3. And I can say z is equal to 1 by 2. So 10 is definitely greater than 1 by 9 is greater than 1 by 16. Right? You see, I'm trying to solve this. I'm trying to prove this to be true. I want to take a value of x to be greater than z to be greater than y. So I'm taking z as 1 by 2. I'm taking y as 1 by 3 because I know 1 by 2 to the power of 4 will give me a much lesser value than 1 by 3 to the power of 9. 1 by 3 to the power of 2 because that's 1 by 9. So that's satisfying my constraint. And x is 10 is greater than half, greater than 1 by 3. Possible. 3 also works. So out goes B. E should be my answer. Right? So this is the mindset that you need to have when you have a could be question. You should try to prove them to be true. And you see, when I picked values, right, one thing I ensured, or two things I ensured. First, I ensured that I satisfied the constraint. I always ensured that I took values that satisfied my constraint. I cannot violate the constraint. And second, I tested for different kinds of values, right? I didn't only limit my thinking to integers. I started with integers because that was the easiest way for me to work. But as soon as I saw that the relationship, they wanted to reverse the relationship, I thought about fractions. If they may have given me, squares and even powers here for maybe another equation, I would have thought of negatives as well, right? Roots are also a good option whenever you have squares, right? Somebody use root to, squares is something that you can definitely utilize here. See, again, guys, you should never look at things in terms of how much time does a question take. This to be, if you go and look up the data, This is a official GMAT question. Okay, so you have to understand that with the harder levels of questions, some of them may require you to spend 2.5 3 minutes to work, right? That the reason for that is some other questions, easy questions, can be solved in a minute, right? So if you're able to solve a question in a minute, then you're it's possible for you to spend 3 minutes on another question and it will still average out to two. Understood? So you'll have to understand this. The key to working with values is not to go with a hit and trial process. Most of you all just randomly try to pick values and try to see what values satisfy and what values work. What did I do? For the first, I saw x is greater than y greater than z. I immediately took integers because that was pretty straightforward, since I had x is greater than y square greater than z to the power of 4. But immediately when I saw that pattern, that this entire relationship was reversed, I thought about it smartly and I said I can work with fractions. That's why I said that whenever you have squares or even powers, right, you should think about negatives to plug in. You should think about roots. Only at that point I would think about a root. If I see that my entire expression reverses, I will think about fractions as a possibility. Right? So I'm just using my knowledge that between 0 and 1, the values keep reducing when you square and when you square and you cube and you take a fourth power and so on. So that is why when I saw that the terms reversed, I picked fractions and I worked with it. Got it? You can try extreme values, but remember, I'll have to ensure that I pick values that satisfy the constraint. Okay, so you can pick extreme. You can take x as 1,000 if you want, but remember, I can't randomly pick values. I have to ensure that the constraint is satisfied. Got it? All right. So let's take a pause here. Let's take a break for maybe a couple of minutes, right? So you can grab a bite to eat, grab a glass of water, and let's continue with the next part, and we'll discuss the remaining properties as well. Okay. I'm still here online. So anyone who wants to ask a doubt can please ask me the doubt here. Instead of trying extreme values from the outset, I have to first pick values. Remember, I need to pick values to satisfy my answer choice, right? And satisfy my constraints. So randomly picking extreme values is not going to help, right? What is my first, focus? My first focus is to pick values that satisfies that condition that x is greater than y square greater than z to the power of 4. Right? No, rhythm. It's adaptive, so maximum questions would be hard. That depends upon how you answered the previous questions, right? So if you've again, you're assuming that the algorithm is as simple to understand, that one easy question, it will go off directly to the harder levels of questions. No, right? They have buckets of questions, right? If you look at it like that, if you answer your first 5 or 6 or 7 questions right, when you start off on a very positive note, you would still get harder levels of questions. But remember, harder levels of questions does not mean every hard question is going to take 3 minutes to solve. Right? Every hard question is never going to take 3 minutes to solve. There would be some questions that will definitely require you to invest some time. There's no other way I can work with this other than putting in values, right? So every hard question, again, you're going with the assumption rhythm that every hard question requires 3 minutes to solve, right? No, it does not, right? Some questions may require that time, but harder questions can be solved in 2 minutes, provided you use the right approach to work. What should be the strategy for could be, must be questions? Simple, Sivadas. I said, right? I'll just show you the slide. What do you do for a must be question? Must be question, you always try to work with it algebraically. Break it down, run through your answer choices, see which of the answer choices caters to all the defined possibilities in the constraint, or try to disprove, right? Negate, try to see which one, which value doesn't satisfy that answer choice. If it's a could be question, I will not try to work with it, algebraically. I'll immediately try to put in values to try to find one case which is true. Because my job in a could be question is to just prove one case to be true. In a must be question, it will be very difficult for me to prove cases to be true by putting in values, because I'll not get definitiveness there. I can't use one set of values and say it's true for all possibilities, right? That is why I'm preferring the algebraic approach, because it's more definitive in nature. Please take next session on number properties. Um, Rachna, we have a discussion on certain topics, right? Maybe number properties is not one. Maybe I would deal with data sufficiency. I would deal with permutations combinations, and that's the sessions in the pipeline. Maybe absolute values as well, right? So those sessions are in the pipeline. Number properties, you know, it would be just way too much of a an overload, right? Because there's already five sessions that are put in, right? And then you also have the verbal bits also coming in. So for the next, say, 5, 6, 7 weeks, we already have set the absolute value bit and data sufficiency, as well as permutations combinations, because I think most of you all had asked for permutations and combinations, right? So next, checking 0 points. Any advice, please? Shivam, I'll have to understand what are you struggling in terms of mocks, right? Because if you're making silly errors, then obviously you'll have to do a like an RCA, right? Of why are you making the mistakes. So if you're see, there's one thing that I normally hear test takers telling me: I make a lot of silly mistakes, right? But they know they make the silly mistakes, but what do they do to counter that? So that's the most important bit. So put in a call to action, right? What do I do if I'm making these kinds of silly mistakes? If I'm forgetting the zero, why don't I write down the constraint, box it up, right, and say that, reiterate that I have to use zero and then work with it, right? All right. Okay, so let's start again. Just last minute, and then we'll start again. Okay. When is the session on absolute values? I think you can look at the schedule, Khyati. um, the admin will put the schedule up, and then we'll give you a date for when the absolute value session is. The next session is absolute values, and post that I'll be dealing with permutations, combinations, probability, and then data sufficiency at the end. Okay. It's a fine line that you have between accuracy and timing, Shivam. So if you write down and box it up, it just take you 10 to 20 seconds extra. No, I don't think that should be you know too much of a concern. Correct. I would prioritize accuracy more than the time aspect of things. No, 20 seconds more just by writing down a constraint, I don't think is going to have that much of a so then if you're taking too much of time on questions and you feel that you have to rush through, then I would look at whether you're approaching the questions the right way. Because the factor that determines how quickly you solve depends upon decision making, right? Decision making is the one that reduces the time. It's not how fast you write, or how quickly you do your calculations, right? It's decision making towards approaching the question. So you'll have to look at, how do I improve that decision making? Am I using the right approach to work with a question? So you'll have to review each of those questions that have taken you too much of time, and see where tweaks can be made to approach questions better. Because cutting out time based on writing fast and not writing down certain conditions is not the best way to save time. Okay. All right. So let's start with the next bit. Okay. So we looked at 4 fundamental rules. Let's look at the other rules as well. These are what we call the advanced rules of inequalities. Okay. Important ones. Like I said, if you're able to integrate these rules into your process of working and breaking down algebraic equations, it becomes very, very simple for you to work. And what I'm also going to do is, the examples that I'm picking after discussing each of these rules, some of them will be must be's and could be's as well. Okay. So what is rule number 5? Rule 5 is the process of adding, subtracting, multiplying, and dividing inequalities. Can you add? Can you subtract? Can you multiply? Can you divide? Where can you do it? How can you do it? So we're going to look at this rule in 2 parts. Okay. The first part is when we work with infinite ranges or inequalities with variables on both sides. Same rules apply for both. Now, let's take 2 infinite ranges. Let's take x is less than 3 and let's take y is less than 3 as well. I'll just take a simple example. Now think about this, okay? If x is less than 3 and y is less than 3, would it be correct for me to say that x plus y is less than 6? Would it be absolutely fine for me to say x plus y is less than 6? Remember, it's like a must be true now. If x is less than 3 and y is less than 3, is x plus y less than 6 always true? What do you think? Is x plus y less than 6 always true? Definitely. Try to counter it, try to disprove it. You will not be able to disprove it. Any value you take for x less than 3 and y less than 3, even negatives, will always give you less than 6. But let's subtract, right? Normally people do this with inequalities. If x is less than 3 and y is less than 3, can I say x minus y is less than 0? Will it always be true when x minus y is less than 0? That x minus y is less than 0 if x is less than 3 and y is less than 3. Again, think about it from the must be true standpoint. If x is less than 3, y less than 3, can I definitively say x minus y is less than 0? I can't. Why? Because if I take x is equal to, let's say, a minus 5 and I say y is equal to a 3, right? Or y is equal to 2. So minus 5 minus 2 is going to be a minus 7. There it's going to be less than 0. But if I take x is equal to minus 5 and I take y is equal to minus 7, minus 5 minus of minus 7 is minus 5 plus 7. That's not going to give me a value less than 0. It's going to give me a value greater than 0. So this definitely is not going to be true. Same way, if I multiply, can I say xy is less than 9? Can I say xy is less than 9? Is it possible? Think about it. Right? It's very easy to eliminate this. Because if x is less than 3, y less than 3, can I always say xy is less than 9? No. Because if I take x to be a minus 5 and y also to be a minus 5, then the product there is going to be 25, right? The product xy need not be less than 9. And can I say x divided by y is less than 1? Clearly not again, right? If I take 2 negative values, x to be a bigger magnitude, then obviously x by y would be greater than 1. So what is the point that I'm making here? That when you're working with infinite ranges or with inequalities where you have variables on both sides, something like a is less than b, when you have such inequalities, the best mathematical operation that you can use between sets of inequalities, provided the inequality signs are pointing in the same direction, is addition. Right? You can always add inequalities provided the inequality signs are pointing in the same direction. You cannot subtract, you cannot multiply, you cannot divide, because subtraction, multiplication, and division will depend upon the signs and magnitudes of the quantities that you consider. But with addition, I don't need to worry about the signs and magnitudes. It'll always hold. So what is the thing that I'm saying here? You can always add inequalities. Addition should be, or addition is the safest mathematical operation that you can use between sets of inequalities, provided the inequality signs are pointing in the same direction. You can always add inequalities, provided the inequality signs are the same. Right? Provided the inequality signs are the same. If they're not the same, you make it the same and then do it. So if I give you x is less than 3 and I tell you, let's say y is greater than 3. Now here I can't add them out directly, but I can say x is less than 3. I can multiply this entire inequality by -1, and if I multiply by -1, I can flip the sign. So I'll get minus y is less than -3. And now I can add them up. So x minus y is less than 3 minus 3, which is 0. So you see, it turns out to be a subtraction anyway. You can make them the same sign always, right? There are two ways you can always change a sign. No, I mean, it's simple logic. No, 3 is greater than 2. The first way I can change a sign is to flip the terms around. If 3 is greater than 2, then 2 should be less than 3. The second way, if 3 is greater than 2, I can multiply the entire inequality by -1. -3 will be less than -2. So there are two ways I can always flip a sign, right? I can reverse the terms, or I can multiply or divide the negative quantity. But if you want to add, you can always add. But if you want to add, the inequality signs have to be the same. So what is the point that I'm making here? If I give you A is less than B, I'll just write it here. So if I give you A is less than B, what can I definitively say? And let's say B is less than C. If I give you these two inequalities, what I can definitively say is that A plus B is less than B plus C. Absolutely fine. What I cannot say is A minus B is less than B minus C. That would be wrong. What I cannot say is AB is less than BC. That would be wrong. What I cannot say is A by B is less than B by C. That would be wrong. So what is the point I'm making? The only mathematical operation you can perform between sets of infinite ranges or sets of inequalities with variables on both sides is addition. You can always add them as long as the inequality signs are pointing in the same direction. If they're not pointing in the same direction, you make them point in the same direction and add. You cannot subtract, you cannot multiply, you cannot divide, because subtraction, multiplication, and division depends upon the signs and magnitudes of the quantities that you have. Got it? So this is what you have to keep in mind for infinite ranges. But what about finite ranges? Right? Adding, subtracting, multiplying, and dividing. Finite ranges. If you're working with finite ranges, you can add, you can subtract, you can multiply, and you can divide. But it has to be done via something called the maximization and the minimization concept. It has to be done based on the maximization and the minimization concept. So if I give you two finite ranges, -11 is less than or equal to x, less than or equal to 12. This is the first finite range. And I give you a second finite range, -9 is less than or equal to y, is less than or equal to -3. I can definitely add, I can subtract, I can multiply, and I can divide, but I cannot directly do it. I'll have to do it via something called the Maxmin concept. What is the Maxmin concept? How do you use it? So whenever you see two finite ranges given to you, right? Whenever you see two finite ranges given to you, or two or more finite ranges given to you, and the question asks you for an addition or a subtraction or a multiplication or a division of the values on the finite ranges, immediately the trigger should be I have to do it via the Maxmin concept. I cannot do it directly. I can do the addition, subtraction, multiplication, division, but it has to be done via the Maxmin concept. What is the Maxmin concept? How do you use it? First step, you place the ranges one below the other. You place the given ranges one below the other. You ensure the inequality signs are pointing in the same direction. Once these two things are done, look at what the question is asking you. Suppose the question was asking me for xy. What will I do? I will solve for that. I will perform that mathematical operation between the extreme values, right? Perform that mathematical operation. Suppose the question asked me, they gave me these two ranges and they asked me information about xy. So what will I do? Instead of multiplying directly, I will perform that mathematical operation between the extreme values of x and y. Work with the extremes. So how would I do that? Let's see. Since I need x into y, I'm going to work with the extremes. So x into y, I'm going to take these two extremes. Minus 11 into minus 9 is plus 99. 12 into minus 3 is a minus 36. Minus 11 into minus 3 is a plus 33. 12 into minus 9 is a minus 108. So all I'm doing is I'm performing that mathematical operation between the extreme values. If it was x minus y, I would have done that same. I would have subtracted the extremes and written the four possibilities. If they asked me for division, I would have divided, got to the four possibilities. So when I'm working with all the extremes, I'm going to get four possible values of x into y. The maximum value out of these four would be the maximum possible value of xy. And the smallest value, that is minus 108 in this case, would be the minimum possible value of xy. So now since I've got the maximum and the minimum, I can get to a range for xy. So I know xy, the range of xy should be between minus 108 and plus 99. And now I can use this range to my advantage to reason certain things out. So I'm working with the extremes. I'm getting to four possibilities. I'm taking the max out of it. I'm taking the min out of it. And then I'm writing my range for whatever they've asked me. So with finite ranges, you can add, you can subtract, you can multiply and divide, but you have to do it with the maximum concept. You cannot do it directly. Okay? You can add them directly, that's not a problem, but subtraction, multiplication, division, it has to be done using the maximum concept. Make sense? So that's your rule number 5. What do you do when you have to add, subtract, multiply, and divide inequalities? When you're working with infinite ranges or you're working with inequalities with variables on both sides, you're constrained only to addition. The best mathematical operation you can use is addition. But if you're working with finite ranges, you can add, subtract, multiply, and divide, but do it via the maximum concept. Got it? Let's take a couple of examples. Okay? Give it a shot, please. Remember, same rules apply. Whenever you see an inequality based question, take the equations, see how you can simplify, break them down. You can break them down using the rules of inequalities, work towards the question. Okay, you can type in your answers in the chat window. Remember, guys, work towards the question. Stay within the purview of the properties. Work towards the question. Keep in mind, when you're manipulating multiple algebraic equations, this is not a finite equation as well, finite range. The only thing that you're constrained to is addition. But the inequality signs have to be set up in the same direction. Okay, so let's discuss. I've been given 4a plus 2b is less than n, and I've been given 4b. I'll just write it as 2a plus 4b is greater than m. Always helps to write the equations one below the other and focus on what the question's asking. The question's asking what is b minus a, right? So immediately I would say, okay, if I subtract these two, 4a, 2a, 2b, and 4b, I'll get 2a minus 2b. And if I get 2a minus 2b, I can think of a minus b from that, correct? But I can't subtract inequalities. I can add them up. But the inequality signs here are not pointing in the same direction as well. So I can either multiply the first with a negative and work, or multiply the second with a negative and flip the signs. I'll choose to multiply the second. So 4a plus 2b is less than n. Minus 2a minus 4b is less than minus m. I'm flipping the sign, multiplying throughout with negative. And now I'm going to add them up. So 2a minus 2b is less than n minus m. A minus b should be less than n minus m by 2. But remember, the question is not for a minus b, it's asking for b minus a. So again, I'm going to multiply both sides by negative 1. So b minus a, the sign should flip, should be greater than m minus n divided by 2. You could have maybe multiplied the first with negative and subtracted as well. That's also fine. I'm just flipping it, right? So this is what you would get. So my answer should be C. All right. So remember, when you're working with such questions, think about the rule. Think about the property that you can use. Your instinct should always be try to solve it algebra and analysis. First, set things down with algebra. Break things down with algebra using your fundamental rules of algebra and bringing in the rules of inequalities. Once you break it down, work towards the question, it becomes very easy for you to process. Okay. Let's try one more. Give it a shot, please. Spend time on the question. Identify what kind of ranges you have. You can put in your answers now in the chat window. Remember, guys, the question always gives you the biggest clue on what needs to be done. Okay. So when you see two finite ranges and the question's asking you for A plus B and addition, so first instinct should be try to make the range for A, try to get to the range of A, try to get to the range of B. And it's two finite ranges, so I can add them up. Right? Okay. Like I said, right, it's important for you to look at the question, understand what the question is asking, and link it to the rules and properties that we have. Again, our entire focus is to break it down using algebra and then try to analyze staying within the purview of the rules that we're going to discuss, right? So looking at the question, I have a finite range for 7a plus 1, a finite range for 2 minus b, and the question's asking me for a plus b. It's giving me two finite ranges and it's asking me for an addition. So the initial instinct should be, okay, I need to find out the range for A here. And here it's better for me to make B the subject, right? So I'm going to subtract 1 throughout, right? I'm going to subtract 1 throughout here. So that will be minus 14. I can subtract and add any quantities I want on any side of the inequality. As long as I do it throughout, it doesn't matter. So minus 14 is less than 7a, is less than 28. And now I can divide throughout by 7. And dividing by 7 is not going to flip the inequality sign. It's going to remain the same because it's a positive. So minus 2 is less than a, is less than 4. So that is the range of a that I have. And the range of b is 19 is less than 2 minus b is less than 23. So I'm going to subtract 2 throughout. So 17 is less than minus b is less than 21. It's a minus b, so I'm going to make it a plus b. So minus 17 is greater than b is greater than minus 21. I'm multiplying throughout by a negative sign, so I need to flip the inequalities. And I'm going to reverse it, right? I want to keep the inequality signs pointing in the same direction. So minus 21 is less than b is less than minus 17. I just flipped it around, right? It's not a property, guys. I mean, if 3 is greater than 2, then 2 has to be less than 3, right? That's what I'm doing, right? So I've got the range for b. You see, I've looked at it and I've kept both the ranges pointing, the signs pointing in the same direction. I need a plus b, right? So I can place them one below the other. With addition, I can directly add them up. Doesn't matter. I told you, every inequality can be added. You can also use the maximum here, right? Using maximum, if you go the maximum route, minus 20, minus 2, minus 21 would be minus 19. Sorry, minus 2, minus 21 would be minus 23. 4 and minus 17 would be minus 13. Minus 2, minus 17 would be minus 19. And 4 and minus 21 would be minus 17. So obviously the value for a plus b should be in between minus 23 and minus 13. This is a plus b. Write that down. Now, most of y'all gave me the answer as D, minus 13. What do you think is wrong? Right? What do you think is wrong? Remember the range. Most of you all didn't write down the range. You all just went and picked these values and you picked one of it. What was the range of a plus b? The range of a plus b is in between minus 23 and minus 13. It's not inclusive of the two. It's not inclusive of the two. And what is my question asking me? What is the maximum possible integer value of a plus b? If a plus b is going to lie between minus 23 and minus 13, non-inclusive of the two, what is the maximum possible value, integer value of a plus b? Minus 14. I need a value in between minus 23 and minus 13, which is the greatest. And that would be minus 14. C would be our answer. So this is where you have to be very careful when you're working with such questions, okay? Because you'll be prone to making these silly errors. Most of y'all skipped the step of writing down the final range. That is why y'all picked up minus 13. If you had written down the final range, you would have realized that the range of a plus b should be in between minus 23 and minus 13. And the question's asking me the maximum possible integer value within this range. And that would be minus 14. Got it? So for those of you who answered the question as D, minus 13, you understand what your mistake was, right? C would be the right one here. Any doubts on this? So you see how we use rule number 5, right? To break down the entire question and to set things up. A very, heavily tested concept as well. The concept of max-min. Miss to consider the less than sign. Yes, normally that's the case, Tushu. That's why I said, right? It's always best to write down the steps, right? In the event of trying to save that 5 seconds or 6 seconds that were taken you to write it down, you let go of the accuracy aspect of things. Okay, so this is where the mistakes happen. So it's always recommended that you write down the steps. You don't need to do like these calculations at the side, but at least the steps need to be written down so that you can observe the equation and then analyze out of it, right? All right, any other doubts, guys? Can we move on to rule number 6? Okay. Okay, so we looked at rule number 5. Let's move on to rule number 6. Rule 6 is when you're squaring and you have to take the reciprocal of inequalities. Again, you just cannot square it randomly. You cannot take the reciprocal randomly. You have to understand when can you square, when can you not square, when can you take the reciprocal, when can you not take the reciprocal, and what happens when you square, and what happens when you take the reciprocal. So let's look at squaring first. Okay, let's understand this by taking an inequality and then like working with numbers. So let's say I give you x is less than y. I'm giving you this. Okay, so if I give you x is less than y, can I square both sides and say x square is less than y square? Is it possible? Can I directly square both sides? Normally, when you have an equality, you would do that, right? You would square both sides of an equality and say x square is equal to y square. So my question is, can you square both sides of an inequality directly and say x square is less than y square? Possible? Yes, no? No? Yes, I just cannot randomly square, especially without knowing what signs x and y takes. Right? Without knowing the signs, I cannot square. So when can you not square? You cannot square both sides when signs are unknown. If you want to take an example, right? I can take x is equal to 2, y is equal to 3. So in this case, x square will be 4, y square will be 9. So clearly x square is less than y square. But now if I take x is equal to minus 3 and y is equal to minus 2, if I take these two values, if I square it, x square would be 9 and y square would be 4. So x square would be greater than y square. So I don't get a definite, relationship between x square and y square. So I cannot square it if I have absolutely no clue on what the sign of x and y is. And I also cannot square if the signs are different. For example, if I take x is equal to 3 and y is equal to 5, let's take different signs. So x is equal to -3 and y is equal to 5, right? If I take different signs, if I take x square would be 9 and y square would be 25. In this case, x square will be less than y square. But if I take x is equal to -6 and y is equal to 5, now x is still less than y, but x square would become 36. Y square will become 25. X square suddenly will become greater than y square. So I cannot square both sides when the signs are unknown or when the signs are different. But I can definitively square if I know the signs of both the sides. If I know the signs of both the sides, I can square. I can square if the signs of both sides is known. If I tell you now that x is less than y and x is greater than 0 and y is greater than 0, I can definitely square it, right? Let's take an example. X is equal to 2, y is equal to 3. So x square will be 4, y square will be 9, x square will be less than y square. So if both the sides are positive, then I can square both sides and say x square will be less than y square. The inequality sign will not be impacted. But if I have x is less than 0 and y is less than 0, if I know both sides are negative, I can still square it. It's absolutely fine for me to square it. But think about it. I'll take two values. X is equal to -3, y is equal to -2. Since I'm taking both negatives, x has to be less than y. So -3 minus 2. If I square it, I'll get x square is equal to 9, y square is equal to 4. So x square will be greater than y square. Right? So what is the rule for squaring? I can never square if I don't know the signs, or if one is positive, one is negative. I can always square if I know the signs are both positive or both negative. If they're both positive, you square it, keep the inequality signs to be the same. If they're both negative, you square it, you flip the inequality sign. Got it? That is what you have to do with squaring. Now, what do you do with taking the reciprocal? So let's look at that. Again, let's take the same equation. X is less than y. Okay? So taking the reciprocal. X is less than y. So without knowing the signs, no, if there is an equal to sign also, the same thing remains. No, there's no change, right? I mean, if it's x is less than y, if it's equal to y, you will just have the equal to sign, right, Vishal? I mean, if it's x is less than or equal to y, if I know both sides are positive, then I will say x square is less than or equal to y square. If both sides are negative, x less than or equal to y, if both sides are negative, I will say x square is greater than or equal to y square. That's all. Right? Whatever rules, guys, whatever rules I'm giving you, even though I'm using less than or greater than, right? All the rules will still apply for less than or equal to and greater than or equal to. I'm not looking at less than or equal to and greater than or equal to separately. Understood? Whatever rules I'm giving you holds good for any sort of inequality sign. I started the topic by saying the inequalities are less than, greater than, less than or equal to, greater than, equal to, not equal to. Even though I'm using an example of x is less than y, it would still hold good for equality. I just have to integrate the equality sign in my solution as well. Right? Reciprocals also work in relatively the same way. There is one difference though. I cannot take the reciprocal. Right? I cannot reciprocal both sides. Not a good English way of working, but I don't want to erase everything. You cannot take the reciprocal on both sides when the signs are unknown or when the signs are different. Still holds good the same way. You can definitely take the reciprocal if both the signs of both sides are known. But it's slightly different to squares though. So let's say if I know both are positive, and remember when I'm taking the reciprocal, I have to worry about fractions as well. Okay. So let's say both are positive. So let's say x is greater than 0 and y is greater than 0. Let's take an example. X is equal to 2, y is equal to, let's take 3 and 2. Be better, right? Let's take x is equal to 3, y is equal to, take 1 as well, but x is equal to 3, y is equal to 2. So x is 2, y is 3, right? So x is equal to 2, y is equal to 3 since x is less than y. So now I'm going to take the reciprocal here. So 1 by 2, 1 by 3. Now 1 by 2 is greater than 1 by 3. So if I take the reciprocal, if I'm working with integers, the sign flips. Let's test for fractions as well. So let's take x is less than y, x is 1 by 3, y is 1 by 2. 1 by 3 is definitely less than 1 by 2. So if x is 1 by 3 and y is 1 by 2, if I take the reciprocal, I'll get 3, I'll get 2. So you see again the sign flips. So how do reciprocals work? If both sides are positive, the reciprocal will always flip the sign. Taking the reciprocal will always flip the sign. So if x is greater than 0 and y is greater than 0, then directly I'll say 1 by x is greater than 1 by y. So I'll flip the sign then. So now let's take the other case. What if I have both sides to be negative? X is less than 0, y less than 0. So let me write that separate. X is greater than 0 and y is greater than 0. Then you know that 1 by x is greater. So let's take x is less than 0, y is less than 0. So let's take two values. Let's again take two integers, two fractions as well. So if I take, remember x should be less than y. So if I take x is minus 3, y is equal to minus 2, what will I end up getting? 1 by minus 3, that is minus 1 by 3. And 1 by minus 2, that is minus 1 by 2. Minus 1 by 3 is greater than minus 1 by 2. So again, what's happening? X is less than y was the initial range I gave you, initial inequality I gave you. That's flipping when I take the reciprocal. Let's test even for a fraction. So x is less than y. So x is minus 1 by 2. Y is minus 1 by 3. X is less than y. So if I take x is less than y, if I take the reciprocal, I'm going to get minus 2. If I take the reciprocal of x. If I take the reciprocal of y, I'm going to get minus 3. Minus 2 is greater than minus 3. So even when both are negative, what happens when I take the reciprocal? The sign flips. So simple rule. If you want to take the reciprocal, you have to ensure that you know the signs of both sides. If both sides are positive and both sides are negative, you can definitely take the reciprocal. And if you take the reciprocal, just flip the sign. Irrespective of whether both sides are positive or both sides are negative, flip the sign. So what will I write here? If x is less than 0 and y is less than 0 and x is less than y, 1 by x would still be greater than 1 by y. Got it? Very, very important. At some points, you may have to take reciprocals. So remember, you can do it in one step rather than struggling with it, right? So with squares, what do you keep in mind? That I can only square when I know the signs. But if I know that the signs of both sides are positive, if I square it, the inequality sign remains the same. Different signs, I cannot do it, right? If you can take you want me to take an example to work? I just told you, right? You cannot take the reciprocal when the signs are unknown or when the signs are different. If you try taking the reciprocal, you'll never get to a exact solution, right? If you try, sometimes it'll be greater, sometimes it'll be lesser, depending on what values you take. So you cannot reciprocal, you cannot square when you don't know the signs or when the signs are different. You can square, you can reciprocal when the signs are the same, right, on both sides. But in squares, if the signs are both positive, the inequality sign, you can square it, the inequality sign remains the same. If they are both negative, the inequality sign flips. In reciprocals, you can definitely reciprocal when both sides are positive and both sides are negative. Simply, when you reciprocal, you will flip the sign in both cases. Got it? Yes, very important property. Again, the rules that I'm setting up here are basically things that you can do to manipulate your algebraic equations and boil it down to a simplest form so that you can analyze. And even if you can't analyze, the simplest form of an equation would be easier for you to plug in values as well. So all of these rules are geared towards that. Okay. Any doubts on this, all of y'all? We'll look at a question and then move to rule 7. That's the last rule, and then we can look at some mixed bag of 2-3 questions and then wrap up. Okay, I may end at around 12:30 today, so hold on till then. Okay, if you're tired, I can really understand that as well. You can have a look at the video, once you're done, once the video is uploaded on the YouTube and the GMAT Club YouTube channel. All right, so any doubts on this? No. Let's go into the questions. Let's take this question. I'll skip question 7 because of dearth of time. Give it a shot, please, all of you. I'll give you a minute. Shouldn't take you more than a minute to solve. Try to integrate whatever we've learned so far. What have they given me about x and y? They're both negative. What should you think about? I can manipulate. Look at what you have. Look at your answer choices. Vishal, think through a little more. Think about it, right? A square can't be bigger than negatives, right? Tushit, be a little careful with your manipulations. Again, I think you've not written down things, so you're making that silly mistake. When you divide, you need to flip signs. Guys, slow down. Don't no need to rush through, right? Trust me, if you're able to understand the concepts, it's very easy for you to work. So what I'm trying to improve is your decision making abilities. The decision making abilities are the ones that will reduce your time. So if you know exactly how you need to process the progress with the question, you can spend time on doing the working slowly, because most of your mistakes will happen because you're rushing through and you overlooked something. Okay, it's a toss up between B, C, and D. Okay. Yes, Tushar. There's always merit towards slowing down and writing things, okay? So you asked me, right? I'm making a lot of mistakes. So you need to learn to fix it. So the question you need to ask yourself is, what did I do to fix that this time? Right? In the second pass on the question. All right. So now it's a very nice question, very simple solution, elegant solution. But if you don't do all the steps properly, you're in slight trouble, right? I saw a lot of B's. I'm getting a lot of C's. I got D's as well. Some people put A but then changed it. But let's look at it, right? Let's remember, guys, focus on the question. Focus on the question, understand what information is given, try to manipulate things and simplify things. Simplification means trying to get rid of variables, trying to put things in terms of products and divisions. And always glance at your answer choices. Your answer choices will give you the biggest clue. Many of y'all have given me B as the answer. Let's see why B would not work. X and Y are both negative. Immediately when I see this, it's wonderful information for me to have. Why? Because it opens up the possibility for me to multiply and divide with those variables. And they've given me xy is less than y square. Now I can definitely use the three golden rules and take the y square to the left, factor out the y, and then try to analyze. But when I just glance at the answer choices, they're giving me x is less than y is less than x, and they're giving me x square, y square. And I know the signs of x and y. So I know it's possible for me to manipulate with multiplication and division. So immediately I will just choose to divide both sides by y because it just gets rid of that, extra y term in that equation, correct? But when I divide both sides by y, I'm dividing both sides with a negative value. I need to flip the signs around. And that's what most of you all did not do who gave me B as an answer. You all didn't flip the sign when you divided both sides by y. When I divide both sides by y, x should be greater than y. So if x has to be greater than y, out goes alpha, out goes beta. Right? Two answer choices are ruled out immediately because both the answer choices give me x is less than y. And now I see, okay, they're giving me x square and y square. And I know both sides are negative. So if I square both sides, the inequality sign has to flip. Right? So x square will be less than y square. And I also know that x square and y square, since x and y are both negative, have to be positive terms. They have to be bigger than x and y. So I know x is greater than y and x square is less than y square. So if x is greater than y, I can say y is less than x. And then I know x square is less than y square. So y should be less than x, is less than x square, is less than y square. C. That is my answer. Let's imagine x is minus 2 and y is minus 3. Right? Okay. Is lesser than 3 square, then C is... I mean, I'm not going to put in values, right? Okay, so you're basing your entire answer based on only checking for x is equal to minus 2 or x is equal to minus 3. The question is must be true. That means that whatever you're picking as your answer choice, Vishal, should always be true for whatever values you pick. Where have you tested for fractions if you're going that route? That is why I am not using plugging in as my first mode of attack. The entire crux of this session was what is the best time efficient ways of working with questions, right? Taking a negative possibility in terms of a number, doable, definitely doable. But if I'm taking negatives, I told you, if you're taking values, put -1, 0, +1. Since they're telling you x and y are both negative, you have to worry about this portion of the number line. Then check for fractions, check for integers as well. I can't base my analysis, especially in a must be true question, with one set of values because it has to be true always. That is why you prefer to work with algebra, because it gives you more definitiveness. And I got the answer in 3 steps. For 45 seconds, I can pick and I can move on. Right? Putting in values is a pain. I'll have to run through my answer choices as well. Got it? Yes, you can do that as well, Sauvik, right? Obviously, what Sauvik is saying is directly I can knock off D and E. That's what he's saying. Right? So I didn't have to do this extra step of squares as well. That's what Sauvik is saying. Why can I knock off D and E? Because x square and y square will never be lesser than y and x if x and y are both negative, because they are positive values. That's a good catch, Sauvik. Right? So I didn't have to do this square as well if I eliminated those two, because only this would have eliminated a and b for me. And no, the very fact that x square and y square is positive, cannot be less than y and x, would have eliminated d and e, leaving me with c. That would be the fastest way to work. Got it? So guys, remember that the algebraic process is beautiful, okay, once it's applied the right way. But that requires 2 things. That requires you to understand what constraints you're dealing with, you to understand how to break down the equations and simplify them, staying within the purview of the rules. You have to understand the rules well, and you always need to work towards what the question is asking. Make sense? So this is your rule 6. Now let's go into rule 7. The last rule, and then we look at a set of maybe 2-3 questions. Rule 7, I would say, is a very, very important rule. It's going to be something that you would normally use to break down very complex equations, especially equations that are dealing with one variable. It's called the wavy curve method. This is the mathematical way of representing this rule. I call it the quadratic inequalities, right? It's actually called the wavy curve method of working. Now, where do we use this? Now, like I said, if some of you all have looked at my old video of inequalities, I would have brought this wavy curve method and worked. So I'm going to elaborate on that slightly. I'm going to put in the same principles, but I'm going to elaborate on what needs to be done. When and where can you use this? When can you use this wavy curve method? Whenever you see any inequation, an equation with an inequality is called an inequation. Whenever you see an inequation where there is one variable that runs throughout, there's only, let me write that word, only one variable. So whenever you say an inequation where there is only one variable raised to any power, all of these kinds of equations can be broken down using the wavy curve method. Equations like this: x square is less than x, x to the power of 8 is less than x to the power of 7, x plus 2 into x minus 3 is into x plus 5 is greater than 0, a cubic equation. Even for a division of values, x plus 5 divided by x minus 3 is greater than or equal to 0. Whenever you have an inequation where there is only one variable that runs throughout, raised to any power, you can use the wavy curve method to simplify and break it down. So where all you can use it? You can use it for a quadratic equation in the form of ax square plus bx plus c is less than greater than 0. You can use it for a cubic. Greater than 0. When I say greater than and less than, it means greater than, equal to, less than, or equal to as well. I can use it for a fourth power, fifth power, sixth power, as long as there is only one variable that runs throughout. The reason for that is when I have one variable that runs throughout an equation, I can solve for that variable. I can also use this process even when I have a division of values like this. Okay, many people think you can only utilize it for squares and cubes. You can use it for a division because I still have only one variable x there. I can use it even when I have an equation like this: plus c divided by px plus q is greater than or equal to 0, right? As long as there's one variable that runs throughout, the wavy curve method is applicable for you to work, right? So how do you use it? What do you do? There are two guidelines that you have to keep in mind, okay? The first of the guidelines, you have to ensure that you set up the equation using the three golden rules. You have to do it. That means you have to keep the right hand side 0. You pull everything to the left hand side. You factorize the left hand side into a product or a division of values, and you factor out even powered terms wherever possible. The three golden rules have to be used here also to set things up. And second, once you factor out all the terms to the lowest form, right? You factor out terms to the lowest form. Once you do that, you have to ensure the coefficient of the variable is positive. Okay, what do I mean by that? It's not necessary for you to do it. I prefer to do it because it avoids making mistakes. It's like this, right? If you have minus x is less than minus 2, even if you have an equation, minus x is equal to minus 2, you will never leave the equation with the negative sign, right? You will remove the negative sign and say x is equal to 2. Here you will remove the negative sign and you flip it and you say x is greater than 2. Even in a quadratic equation, if I give you minus x square plus 5x minus 6 is equal to 0, you will remove the negative sign on the x square and work, right? So the point I'm making here is, if you break down the equation and you factor the equation into its lowest form, if you get something like this, x plus 3 into 1 minus x is less than 0, you can still work with it, right? I prefer to make the coefficient of that plus, because then I'll be able to use my number line much better. So I will multiply throughout by negative and I'll say x plus 3 into x minus 1 is greater than 0. I'll multiply throughout by negative and I'll flip it around. Got it? I'll always ensure that the coefficient of the variable is positive. The reason for that is when the process that we are going to use, we are going to place some critical points, the roots on the number line. If you don't do that properly, you'll have to be careful in putting the roots. So just to avoid any confusion, I'm just asking you that when you factor things out to its lowest form like this, try to always maintain the coefficient of the variable as positive. Doesn't matter if there is a 2 or a 3 or a 4. As long as it's positive, you will be able to put the roots properly on the number line. So two things you have to understand here. I've not even gone into the process of working yet. You have to understand where to use it, and you have to understand how to use it. Where do you use it? Whenever you have one variable that runs throughout in the equation. A square, a cubic, division, doesn't matter. As long as there's one variable running, I can break it down using the wavy curve method. How do I break it down? I have to set things up using the three golden rules. I have to break down the equation to its lowest factored form. And I have to ensure that in the factored form, the coefficient of the variable is positive. These three things, if you ensure, you'll be able to work with this very quickly. So let's take an example, okay? Since I started with the quadratic, let's take a quadratic. X square minus 5x plus 6 is less than 0. And let's say you are asked to solve for x, or you're asked to break down this equation. So I'm going to first look at this and I see that I have one variable that runs throughout. Whenever I have one variable that runs throughout, I can break it down using the wavy curve. I have to respect the three golden rules. The right hand side is already 0. I don't need to worry about it. The left hand side is not broken down into a product. It's a quadratic. So I can write this as x minus 3 into x minus 2 is less than 0. So I have broken down its factored form, the lowest factored form. Remember, the factored form will always be terms where you have a power of 1, right? That's the lowest factored form. And I also see that the coefficient of the variables is positive. No problem. This is done. I have set it up nicely now for me to use the wavy curve method. So what do we do in the wavy curve method? First step. Suppose these were equal to 0. X minus 3 into x minus 2 was equal to 0. Then if the product of these two terms was equal to 0, then I would say x is equal to 3 or x is equal to 2. These would be the two roots, is what we call solutions, what we call. So here as well, right? Even though we have a less than 0, let's place the two solutions, the two roots on the number line. What are the two roots? The plus 2 and a plus 3. These are what we call critical points, okay, on the number line. So we place the roots on the number line. For those of you all who want to go the analysis process and work, you can do that as well. You can say the product of these two is negative, so I can have this positive, this negative, run that possibility, solve this negative, this positive, run that possibility, solve, and then find the overall solution. But that's not a very nice, time efficient process, right? So what am I doing? I'm placing the roots on the number line. Those are what we call critical points. And once I place the critical points on the number line, the critical points divide the number line into three portions. The portion to the right of 3, the portion in between 2 and 3, and the portion to the left of 2. By default, always, irrespective of how many critical points you have, start with the extreme rightmost region. And by default, place the sign of that region as positive. It will always be positive. Now, why will it always be positive? Take a value in this region. X is greater than 3. So take x is equal to 4. Put it back into this equation. 4 minus 3 is positive. 4 minus 2 is positive. It's beyond the two limits of these two equations, right? So obviously the two values I get is positive. Two positives multiplied will always give me a value greater than 0. So by default, start with the extreme rightmost region. Place that sign as positive. And then alternate between the signs moving from right to left in each of the regions. So plus, minus, plus. Just start always. It doesn't matter how many roots you have. Start with the extreme rightmost region. Place that as positive. And then alternate between the signs moving from right to left in each of those regions. It's called a wavy curve method because for those of you who have done a little bit of engineering, that's how a sine wave looks, right? This is how a sine wave looks with crests and troughs. If you didn't do it and you don't know what a sine wave is, just forget I ever said it. Okay, just start with the extreme rightmost region as positive and move from right to left, alternating between the signs. That's it. That's all you have to do. This will give you your answer. In one step, you'll get your answer. The answer here will depend upon the right-hand side of the inequality that you have. What is the right-hand side saying? This product should be less than 0. So if it's less than 0, if the right-hand side is less than 0, my solution should be in the negative portions of my number line. If it's greater than 0, it should be in the positive regions that I've marked. So it's less than 0. So this is the negative region that I have marked. Right? It doesn't include the 2 and include the 3 because it's not equal to. So the solution to that equation is x has to be in between 2 and 3. That will be the solution to that equation. Okay. It's very important for you to understand this because we're going to utilize it in multiple variations. So again, 3 golden rules. Factor it out its lowest form. Ensure the coefficient is positive. Place the roots on the number line. They are called critical points. Start with the extreme rightmost region. Place that as positive. Move from right to left, alternating between the signs. Look at the right-hand side of the inequality. And then choose based on what the right-hand side is. If it's equal to, doesn't change. I told you guys, whatever I'm doing holds good for everything, right? If I have a less than or equal to, I would just include the boundaries, right? Equal to means it includes the boundaries, right? So if it's less than or equal to 0, I would include the boundaries. So then my answer there would be x is between 2 and 3, inclusive of 2 and 3. Got it? Guys, no difference between a less than and a greater than and less than or equal to greater than or equal to. The only difference is all rules apply for those as well. The only difference is if it's less than or equal to, you have to include the boundaries that you take. If it's greater than or equal to, you include the boundaries. So if this was greater than or equal to 0, then I would take everything to the right of 3 inclusive of 3 and everything to the left of 2 inclusive of 2. So if this was x minus 3 into x minus 2 is greater than or equal to 0, then my solutions will be x is greater than or equal to 3 or because there's no overlap. X is less than or equal to 2. That would be my answer. Got it? The same thing I can do even if I have a cubic. So even if I have something like x plus 3 into x minus 5 into x plus 1 is greater than or equal to 0. I'll include the equal to, okay, here. So let's say we are going to solve for x. So again, we'll do the same thing. Here I've already given you everything in its factored form. I already see that the coefficients are plus 1. So it's a very nice form. The right hand side is 0. So immediately I'll just plot the roots on the number line. What are the roots here? Minus 3, plus 5, minus 1. Place it in the correct order on the number line. Minus 3, minus 1, plus 5. Start with the extreme rightmost region. By default, place the sign as positive. And then alternate between the signs moving from right to left. Now look at the right hand side. It's greater than or equal to 0. So my solution should be on the positive portions of the number line, inclusive of the boundary, because it's inclusive of 0 as well. So what would be my solutions? X should be in between minus 3 and minus 1, inclusive of minus 3 and minus 1, or X should be greater than or equal to 5. That would be my solutions. Simple. So even for a cubic, I can work with it. Even if I have a division, right? Even if I have a division, x plus 3 divided by x minus 2 is greater than or equal to 0. Now, this is, something that normally people will not use this process to work. Normally what they'll do, they'll say both sides, those numerator, denominator is positive, they'll run a solution for that, negative, they'll run a condition for that, and it become a mess, right? Imagine if I given you two terms in the numerator and one term in the denominator. I can't take all sign combinations to work. I can still use the wavy curve method to work with this. The only thing is I have to do one step extra. Okay. Let's see what the step is. The numerator and denominator are already broken down to its factored into lowest forms. The right hand side is greater than right hand side is 0. The left hand side is already factored into product or division of values. It's already in the form that I want. So I'll just place the roots. Doesn't matter if this term is in the denominator. Place the roots. What are the two roots? Minus 3 and plus 2. I'll put it in the correct order. Minus 3 plus 2. Now, I'll again start with the extreme rightmost region. Plus, minus, plus. It's greater than or equal to 0. So I'll include the positive portions inclusive of the boundary. Right? I'll do one extra step though. Let's come to that later. So first, I have greater than or equal to 0. Let me write the solution. So x should be greater than or equal to 2, or x should be less than or equal to minus 3. But when you have a division like this, you have to do one extra step. And that extra step is in your solution. If you have in your solution the value that makes your denominator 0, you will have to discard that solution. So the extra step that you need to do when you have a division like this is, if your solution contains the value that makes the denominator 0, you have to discard that solution. So I have to remove the x is equal to 2, and what I'm left out with is the solutions to that equation. I can have the numerator to be 0. 0 divided by something will always be equal to 0. It's equal to also. I can't have my denominator to be 0, right? I can't have my denominator to be 0. X is less than 2. Shweta, x is greater than 2, no? Right? Because I need greater than or equal to 0. It's to the right, right? This is the region I want. Correct? Got it? Guys, greater than or equal to 2, those who are putting, I cannot include the 2. I have to discard the solution. That makes my denominator 0. That is the only extra step I have to do when it comes to working with divisions like this. All right? Any doubts on this? It's very important that you understand this. Any doubts? Okay. Let's look at a question. Give it a shot, please. We'll work with this, take one more question to consolidate everything, and then we'll wrap up. Okay. The other questions that I have but didn't have time to work, I will write down solutions to them and share the PDF with you. All right. Within the question is not asking you for the range, it's asking you for how many values of x will satisfy the condition, right? For those of you all who are saying E cannot be determined, guys, you've not read the question carefully. Don't forget that they're telling you X is a positive integer. That's why I said be very careful. Most of you all are making this mistake. You are just getting so caught up in the working of this that you're overlooking one piece of information, that too in one line of reading. So be a little careful. Write down the constraints. So somebody had asked me before, right? I'm making a lot of mistakes. I'm forgetting these cases. That is why it's important for you to write down X is a positive integer, box it up, right? And then analyze. It's all about analysis. Solving it anyone can do. Breaking down the equation is very easy for you to learn. But then when you after you to break down the equation, taking stock of all the information and then reasoning out your answer, that's the most important bit. So you see, a hard question is not difficult because it's hard in terms of calculations, right? It's tricky because they'll give you some other factors that you have to consider as well. Okay, so let's look at it. Like I said, I'm always going to spend time on my question. X is a positive integer. Normally, in an inequality question, if they give me this information, it's like a boon to me because I can manipulate with that variable. But when I see this, I know I have one variable that runs throughout, right? So I can definitely make use of the wavy curve method, right? So I need to first respect the three golden rules. I have to set the right hand side 0, the left hand side is a product or a division, and I have to work with factoring it out to the lowest form. So if I have x minus 2 divided by x square minus 13x plus 36 is less than or equal to 0. So x minus 2 divided by x, I think it'll be minus 9 and minus 4, right? So x minus x square minus 9x minus 4x plus 36 is less than or equal to 0. So x minus 2 divided by x into x minus 9 minus 4 into x minus 9 is less than or equal to 0. So x minus 2 divided by x minus 4 into x minus 9 is less than or equal to 0. So I've broken it down to its lowest form, right? Now I'm going to plot it out. I'm going to plot out all the roots. So it's going to be plus 2, plus 4, plus 9. So plus 2, plus 4, plus 9. Start with the extreme rightmost region. That's positive, negative, positive, negative. It's less than or equal to 0. So my solution should be on the negative portions inclusive of the boundaries. I'm shading it. Negative portion inclusive of the boundaries. So x should be less than or equal to 2, or x should be between 4 and 9 inclusive of 4 and 9. But I said when you have a division, you have to discard the solutions that make your denominator 0. So what are the solutions that make my denominator 0? Equal to 4 and equal to 9. I'm going to remove them as part of my solutions. So this is my entire solution. The question is asking me if x is a positive integer. So x is defined as a positive integer already. How many values of x satisfy this equation? So basically, x is less than or equal to 2 means the values, if x is a positive integer, the values that will satisfy this equation are 1 and 2. And between 4 and 9, the integer values would be 5, 6, 7, and 8. So 1, 2, 3, 4, 5, 6. That would be my answer. So you see, a tough question on the test, but once you know the process, it becomes easy. But you still need to understand that you have to set things up and evaluate, take stock of everything and work. It's a reasoning based test at the end of the day. So getting to this point is you've done the hard work, but then you have to set up things and observe what you have and then pick the right answer. Most of you all didn't do that, right? You all didn't eliminate the denominator. Some of you all didn't do that. Some of you all put in the solutions, forgot that x is a positive integer. Most of you all did that. Didn't forget. I mean, I can understand it's tiring as well. But ideally, right, you should never forget the constraint that the question provides. Got it? One more thing that I wanted to touch upon as well is, what if I had given you an equation like this and I asked you to solve for x? Right? Like I mentioned in the start of the session, the 3 golden rules. So if I was working with this, right, I would say x to the power of 8 minus x to the power of 7 is less than 0. I would not pull out x to the power of 7 common. I would put out x to the power of 6 common and written this as x square minus x is less than 0. And I would ignored this x to the power of 6 term because it's always going to be by default positive. And my focus would be on x square minus x being less than 0. Now I will be able to solve. So this is what you'll have to do. So the third of the golden rules was factor out even power terms and ignore them. That's what I'm doing. So if I see an equation where it's possible for me to factor out an even power term, I'll take that opportunity. Why? Because it reduces the calculation for me. Even power terms are always positive. Now I can break it out. I can take x common into x minus 1 is less than 0. I can put the roots on the number line. The roots will be 0 and plus 1. It's the same as what you would do, guys, when x minus 1 is equal to 0. So you'll say x is equal to 0 or x is equal to 1. I'm placing the roots. That's called critical points. Plus minus plus. It's less than 0. My solution should be in between 0 and 1. Got it? So even if you have something like this, right, really large terms, don't be afraid to take out the even power term and ignore it. Got it? Up for a last question to consolidate everything, or let's stop here? What do you say? Last question for the day? Okay. No answer. Okay. Last question. All right. So let's take this last question. It consolidates everything that we have discussed so far. It reiterates the Viveka method. And yes, it's a difficult one. And it's a must be true question in addition to it. Okay. Give it a shot, please. All of you. Try it out. Guys, remember what is the rule for a must be question? The rule for a must be question is a statement can only always be true if it caters to every possible value that the constraint defines. Okay, again, I'm repeating what I said. It's very important for you. It's a difficult concept to get your head around. So, the simplest way to look at it is if I'm saying something has to be true always, it can only be true always if it caters to every possible value that you have defined in the limitations. Understood? Simple, guideline of working. Anything that has to be true should satisfy whatever constraints that I have throughout. It should cater to every single value of what the constraint defines. Lots of changes in answers. It's a tricky concept. Or negate it. Negate the answers and try to find out, try to disprove it. Again, I'm repeating, guys, for those of you who are confused, right? You need an answer. Something can only always be true if it caters to all the possible values that the constraint defines. So obviously it depends on how you've broken down this as well. I'm hoping most of you all have broken it well. Okay, let's work with it. It's a wonderful question. Consolidates a lot of things that we discussed. So we have a to the power of 5 is less than or equal to a. So I told you, whenever you see something like this, you see there's an opportunity to break it down, take that opportunity, use the rules and break it and work with it. Don't approach it by putting in values. So a to the power of 5 minus a is less than or equal to 0. The tricky aspect is working with this. Okay, so if you made a mistake here, see where you made your mistake. I take a common. A to the power of 4 minus 1 is less than or equal to 0. I can't stop here. Remember, guys, I have to break it down, factor it out to its lowest form. Right? I have to factor out its lowest form. So a to the power of 4 minus 1, you should be able to identify it as a square minus b square. So a into a square minus 1 into a square plus 1 is less than or equal to 0. Now I take a step back, I pause. What did I say? The three golden rules. Ignore, factor out the even powered terms and ignore it. A square plus 1 is always going to be the even powered term. No matter what, it will be positive. So I can ignore that positive term. It's same as what you would do with x square y is less than 0. You ignore this. If I have x plus 1 whole square into y is less than 0, I would still ignore this. That's positive and y should be less than 0. Right? So the key aspect is for you to use the three golden rules to break it down. That means your algebra should be strong and your understanding of the rules should be good. So I'm going to ignore the a square plus 1 term. I'm left with a into a square minus 1. A square minus 1 is also in the form of a square minus b square. So a into a minus 1 into a plus 1 is less than or equal to 0. This is the factored form of that equation. Now is where I can place it on the number line. If all of you have placed the number line directly with the square term, it would not be right. Okay, you have to factor it out to its lowest form. It's like you solving for a quadratic equation, right? I can't just directly equate and say x square is equal to 4. I have to break it down as x minus 2 into x minus 3 is equal to something, is equal to 0, and then find out the values of x. So I've broken down to its lowest form. Now I would work with it. So what are they telling me? I have the roots as minus 1, 0, plus 1. Some of you would have made a mistake here, or wouldn't have put 0 as part of your solution. 0 is also a solution. Now start with the extreme rightmost region. Plus, minus, plus, minus. The right hand side is less than or equal to 0. So I need the negative portions inclusive of the boundaries. This is also a negative portion inclusive of the boundary. So what is the solution here? A is less than or equal to minus 1 or A is between 0 and 1 inclusive. This is the constraint that the question gives me. So what is the question telling me now? If A is less than or equal to minus 1 or A is between 0 and 1 inclusive, which of the following must be true? Which of these answer choices should always be true? Which of these answer choices should cater to all the possible values that are defined for A? That's how I have to look at it. Which of these answer choices caters to all possible values that are defined for A? So I take minus 1, I take the first one. The first one says A is between minus 1 and 0 inclusive of minus 1 and 0. But here A is also lesser than or equal to minus 1. It can be less than minus 1 as well. This doesn't cater to all the possibilities for A. Neither does it cater to the values between 0 and 1. It can't be true always. So if 1 goes, I know B is not a possibility, E is not a possibility. Right? A is equal to 0. If you don't want to do that also, it's fine. Run through your possibilities, right? If A is equal to 0, A can be equal to 0, but A can also be equal to 1. A can also be less than or equal to minus 1. This doesn't cater to all the possibilities for A. How it goes that. And A is between 0 and 1, inclusive of 0 and 1. Great. It satisfies this. It takes care of this possible values of A. But A can also be lesser than or equal to minus 1. That doesn't cater to that. Out goes that. Alpha. That's my answer. Got it? If you apply the answer choices one by one, you're in for a big problem. You'll definitely go wrong. And putting values is a pain. A very good question, okay? It just consolidates whatever we've discussed so far. Understood? Any doubt? Fantastic. So I had maybe three extra questions that I skipped over because of dearth of time. Yes, that is what I'm saying, Rachita. Right? It should, for like I said, right, for anything to be true always, it should cater to all possible values that the constraint gives you. Understood? Isn't 3 will always be true? How will this always be true, Tushit? A can also be equal to minus 1, no? Based on this. So you're telling me A should only be between 0 and 1 inclusive? That is what the question is. You have to understand the question. Remember, the question is a must be true. Right? If you're telling me A should be between 0 and 1, you're telling me A should only be between 0 and 1 inclusive of 0 and 1. And A cannot be anything else other than that. That is the meaning of must be true. That A should only lie between 0 and 1 inclusive of 0 and 1. Does A only lie between 0 and 1 inclusive of 0 and 1? Definitely not. A can also be less than minus 1 or equal to minus 1. Got it? So you have to be very careful. Must be true, guys. Your critical reasoning mindset should work here. I need an answer choice that caters to every possible value of the constraint. All right. Fantastic. So this is all that you require, guys, for the topic of inequalities. Okay? Everything that you require. What I would suggest for you to do, some people I think joined the inequality session directly today. I would suggest for you to go through the algebra video as well. It gives you a lot of value add, especially gives you clarity. I saw somebody putting about square root and so on. It gives you clarity on square roots, how to multiply, whether to cancel variables. So that video gives you a lot of clarity. And second, go through this video again, make your notes on it. I will give you the PDF by tomorrow. The questions that I have not solved in the session, I will handwrite solutions to it and you will have them for your reference. Okay, so you can just take the PDF, take a screenshot, make it your notes and work with it. Remember, guys, tomorrow you have a wonderful session by Marty on CR, right? Please ensure that you attend it and gain a lot of things. Gain, I mean, I've always watched Marty's videos and they're wonderful, right? They've always helped me out. So I want you to also work with it, right? I know it's going to be a hard 2 days, but I think it's wonderful to interact with you guys from a tutor perspective as well. All right. So last call if you have questions. Shivadas, I think the next date of the session we'll let you know. I definitely will have that session. We'll discuss absolute values mostly during that session, and then post that we work with PNC and permutations as well. Probability. I have probability. I'll do probability first, okay, because that's important even from a DI perspective. But the sessions will tell you the exact dates once all our schedules are also there. But definitely we will have that session. Okay. Any last questions, guys, before we wrap up? I know it's been a long, hard day. Thank you for staying, here. Please like the video, subscribe to the channel, stay subscribed. You will get all the information that is necessary. And I will see you maybe in 2 to 3 to 4 weeks of time. Okay. Any doubts, guys? I need a DI session also. Very difficult, because there are also others. I think your verbal sessions also going to be there. I think verbal, to be very truthful, for DI, verbal critical reasoning and RC is a lot more important. I think attending Marty's session will also be useful for people who are working with DI as well. Okay. All right. Any last questions before I log out? It's been a tiring day for me as well. All right. Thank you, guys. Thank you so much. Hope to see you again. I hope the session adds value and you use this for your prep, right? What is the range of four? Why didn't we count 4 and 9? Because Karthik, 4 and 9 were in the denominator as well, right? So x minus 4 into x minus 9. If you have something in the denominator, right, and it is less than or equal to 0, greater than or equal to 0, I cannot pick the solutions which make my denominator 0, right? You can't have anything to be divided by 0 because it's undefined. Got it? The time, Rajiv, is the same, 9 p.m. IST. Okay. 9 p.m. IST. Mark it in your calendar. Tanmay, I'm doing the absolute value questions, the session on absolute values after this. Okay. It is going to be only pertaining to absolute values with inequalities integrated. I couldn't do both of them together because it's a very large topic. Got it? So there will be a session specifically for absolute values. The session today is specifically on inequalities only, because only if you gain a mastery of inequalities can you go to absolute values, because they have inequalities integrated with them as well. All right. All right. All right, guys. Good night. I'll see you next for the absolute value session.